All right, welcome everyone to our final 4020 presentations. Thank you to the clients, the peers, and the faculty members who are joining us today. My name is Maddie Yerksa, and I'm joined with Gavin Best, and we are going to be your moderators today. And I'm going to pass it over to Gavin to go over some housekeeping items.
Good morning, everyone. Each presentation is going to run around 25 to 30 minutes with about 10 to 50 minutes for questions. If you have questions and you're online, just send an email to the email attached to the end of each presentation. There's going to be 4 presentations in the morning, followed by lunch, and then 3 presentations in the afternoon. Good luck to everybody, and it's going to be a great day.
And now I'm going to ask the members of the Boars Nature Preserve Project to come up and start us off today.
Good morning, everyone. I'd like to begin by acknowledging that the land on which we gather and the land we've all been tasked to manage resides in the traditional and unceded and unsurrendered territory of the Wolastoqey, Mi'kmaq, and Passamaquoddy people. I would first like to extend a warm welcome to Courtney LaRue, Shweta, and Grace of the Nature Trust. We are so excited to present our ideas with you today. Today we'll be presenting our polished management plan for the Boars Head Nature Preserve. We've worked hard all year, and we are so excited to share with you. Since September, we have been working closely with Courtney of the Nature Trust of New Brunswick to develop a management plan for property in their possession. The Nature Trust of NB is an NGO which seeks to acquire properties through purchase or donation and manage the said land for the purpose of conservation and stewardship. Since 1987, the Nature Trust of New Brunswick has conserved over 5,500 hectares of land spread across 90 properties in the province. We've been working with the Nature Trust to preserve and enhance the conservation value of a property located in Milledgeville, St. John, known as the Boars Head Nature Preserve. The preserve is a 24-hectare patch of forested land that banks on the Kennebeckasis Bay. It is surrounded by suburbs, new housing developments, as well as a primary school, community center, and a church. The Boars Head Nature Preserve property was acquired by donation from the province in 2009. It is now classified under the IUCN Protected Area Management, Category 1B Wilderness Area in Canadian Protected and Conserved Areas database. The vision for this preserve is to conserve the wilderness character, unique habitats, and species that it hosts, as well as manage the increasingly prevalent anthropogenic impacts of outdoor recreation and other threats, while maintaining a positive relationship with the local community who use and value this preserve. We have identified some key stakeholders to this property. Our internal stakeholders are the Nature Trust Board of Directors, Trustees Emeritus, the Nature Trust staff, volunteers, and donors. Our external stakeholders are the Anchorage Avenue residents, Samuel de Champlain School, the Department of Tourism, outdoor enthusiasts, and the media. We have come up with 7 environmental objectives and 7 social objectives to measure our progress made towards our clients' goals, and we have been tracking our progress accordingly. We will circle back to these objectives after Molly and Charlotte run you through our results and recommendations.
We have organized our tree inventory data into 5 ground truth stands. The largest is the softwood stand at 9.9 hectares. By stand, we also organized average tree height, DBH, basal area per hectare, snag density, and carbon storage. We found that snags and the volume of coarse woody debris were most abundant in the mixed wood stand, which is marked by the darkest green on the map. We collected data on regeneration to gather information on the future of the forest. Balsam fir was exceedingly the most abundant regeneration species at over 800 stems per hectare, which was followed by red spruce and alder. The most common height class was 2. The alder stand had the highest vegetation percent cover, while balsam fir had the least. The softwood stand had the highest bryophyte percent cover, and the eastern white cedar stand had the highest rock percent cover, while the alder stand had none. We identified 12 patches of Anticosti aster on the shoreline of the Kennebeckasis Bay, and for each patch we counted the number of stems and measured the radius. Despite our efforts, there was no maidenhair spleenwort, wrinkled shield lichen, or white rim shingle lichen found on the property. We used Google Earth images to calculate an annual rate of erosion from 2020 to 2024, accounting for the changes in tide, and we found that it was 0.375 meters. 2 streams on the property were given indicator classes based on vegetation loss, bank undercutting, and anthropological presence, which were F4B and F4C. Based on these, we gave them a morphological quality index, both of 1, which meant that the streams were not heavily altered by humans and are relatively healthy. Our salamander survey resulted in 1 unidentified salamander sighting, and although there were seasonal constraints to our survey, it indicates that there's plausible habitat for the salamanders. We used 5 leaf bag traps on the stream to gather information on the EPT index. We concluded that plots 2 and 3 had an EPT index greater than 50%, which is what we were looking for. We'd like to note that plot 5 was found out of the water, and that might have contributed to its low value. As we walked the unofficial trails in the preserve, we tracked our GPS location using landscape conservation software. For each of these trails, we did condition class surveys where 1 is the least damaged and 4 is the most severely damaged. Out of all these unofficial trails, only 1 was out of 4, and the rest were at 2s and 3s. For these trails, we also used the 7-point hazard tree rating system on a 5-meter buffer of either side of the trails to gather information on what trees will need to be removed. For each of these hazard trees, we photographed and uploaded them to landscape. We did the same for the official trails and found a total of 44 hazard trees. There are 4 sites on the property where infrastructure needs updating. 3 of these are stream crossings, which could benefit from bridges, and 1 is a bank erosion site, which could use stairs. The photo on the left is an impromptu stream crossing in the eastern white cedar stand. The second photo is of the bank erosion site where visitors commonly jump down to access the shoreline. The third photo is a stream crossing in the middle of the preserve, and the last photo is the main entrance. We took photos of the official signage within the preserve because the legends were not aligned with the map layers. Only the trail layer is present on the map, while the legend indicates that there should be a "You Are Here" marker, a stream layer, and wetlands. We remapped the official trail network, tracking us with GPS with landscape as well, and it included an official access point to the shoreline, which was marked by a green tag from the Nature Trust, but not on the official signage. We examined 3 property owners on Anchorage Avenue who share a property boundary with the preserve, and by 2013 we found that all properties had been encroaching, and currently property 2, which is the middle house, is encroaching the furthest at 12 meters. Because wildlife are not restricted to the 24-hectare property, we made patch size estimates, 1 more conservative, not including gaps connected by dirt roads, at 54 hectares, and 1 more generous estimate, including the gaps connected by dirt roads, at 79 hectares. This is to consider how adjacent forest management might impact the preserve. We gathered social data using QR codes that were posted physically within the preserve and online on local Facebook groups. We had 10 participants, and of these, 60% were satisfied with trail infrastructure and believe that the trails are accessible, while 80% found the trail system easy to follow. We also reviewed 67 reviews on the All Trails website from 2020 to 2024. We've created 3 areas of recommendations: trails, social, and environmental, and I'll begin with the trails. We recommend that the Nature Trust implements annual hazard tree surveys on a 5-meter buffer of all official trails, following our methodology from the fall. And we've also created a new map of the trail system using the incorporated trails and the newly mapped trail layer, which can be laid on top of their existing signage, like so. Our recommendations regarding restoring or incorporating trails are based on the fact that Boars Head is classified as an IUCN Class 1B protected area and considers literature on unofficial trails. The largest unofficial trail was recently incorporated by the Nature Trust last fall, so we don't recommend incorporating anymore. Trails 4 and 6 are recommended for passive restoration because their damage is minimal, and this looks like blocking off their entrance and allowing natural succession to occur. Trail 5 is recommended for hybrid of passive and active, and Trail 3 is recommended for active restoration, which looks like blocking off the entrance to the preserve and planting early successional species that are found within the property and monitoring these. We also recommend installing these signs which consider sign pollution and are bilingual. As well, we've written an example letter for property owners who have created trails 1, 2, and 7, which connect from their yard into the Boars Head Preserve. We recommend that the Nature Trust partners with the Samuel de Champlain School for a garbage bin, where a student volunteer can be responsible from September to June, and a local Nature Trust volunteer can be responsible in July and August. We also recommend that the Nature Trust staff repairs the 4 infrastructure points in June 2025. We've created 2 bilingual signs that describe ecological features on the preserve. As well, we have written 2 matching podcast scripts. Trail users could access the podcast once it's been recorded through the QR code that's on the sign. There's one for the Eastern White Cedar Forest, and here's one for the Alder Swamp. Our client has also expressed interest in trilingual signage using Indigenous language that's appropriate to the territory which the preserve is on. So we have the contact of the language coordinator for the Woolstickway Tribal Council for more information. This could be to add language to these signs or to the podcast. With that, I'll hand it over to Charlotte.
All right, so I'm going to be diving into the social recommendations for the preserve. As we know, encroachment on the preserve is an issue. So we have drafted a letter that the clients could send to the homeowners on Anchorage Avenue that outlines the extent of this encroachment. In New Brunswick, the Boundaries Confirmation Act provides a resolution to boundary disputes without proceeding to court through a 4-step legal process. So we outlined this in our report, and this could be followed if the letter does not provide sufficient communication. The client already has a surveyor that surveys the property boundary annually, so we would recommend to continue this. As noted previously, the students at Samuel de Champlain High School have been degrading the preserve, so we have a 3-pronged approach to address this. The first is the garbage bins that Molly mentioned earlier, which incentivizes the students to be stewards of the preserve. Another recommendation is to provide them with a space for an outdoor classroom. The space that we recommend is to the left of the entrance of the preserve, and this is an area that is already used and a bit degraded by students. It is on the school's property, however, it does border the preserve. And we recommend that the educators at the school apply for the Conservation Council of New Brunswick's Learning Outside project. So this project allows teachers to get funding for outdoor classrooms and purchase things such as smooth log benches. Lastly, we recommend that the Nature Trust of New Brunswick does an annual nature walk with the outdoor pursuits class of the preserve so they can teach them about their mission, about the preserve, and about why it's important to protect places like this. And we also created these lesson plans. This is the list here at the bottom with appropriate age groups. And these lesson plans have been developed and can be given to the teachers at Samuel de Champlain School. And this can provide a way for the classrooms to incorporate the nature preserve into their learning so the students can appreciate the preserve. For our general community engagement, we recommend an annual town hall meeting. And so this could occur at the Milledgeville Community Center and could invite different members of the community, the retirement home that's nearby, the neighboring properties. And we recommend that the Nature Trust could talk about their mission, potentially get new donors, new volunteers, and engage with the community. The Nature Trust also has a large following on social media, so we wanted to recommend a social media post that could highlight Boars Head. So we thought a fun way to do this would be to talk about our carbon storage calculations. So we created these 2 slides that could be used for an Instagram post, a Facebook post, LinkedIn, and we also wrote a bilingual caption that talks about carbon storage and its importance for mitigating climate change. A social aspect of concern is illegal activity. We did talk about encroachment and the school, but we also wanted to talk about the general illegal activity. So on the left and the right are examples of tree cutting on the preserve. In the middle is an example of people cutting down trees for wood. And there has also been baiting for hunting and hunting blinds on the preserve. So our recommendation is to incorporate this into the agenda at the town hall meeting so that citizens can learn about why it's illegal. And we also recommend setting up a Facebook group for Boars Head Nature Preserve where community members could report on illegal activity for the Nature Trust. Moving on to our environmental recommendations, our modeling team conducted a sensitivity analysis to predict the rate of erosion on the shoreline given rising temperature and sea levels. So this is one of those scenarios. On the y-axis, we have rate of change. On the x-axis, we have the years. So the blue line depicts what we've already noticed in terms of erosion and tracked using Google Earth. And the orange line is the predicted erosion rate of change given rising temperatures and sea levels. Due to the site being a protected nature preserve, hard engineering techniques such as seawalls are unrealistic, and soft engineering techniques such as replanting are unfortunately not feasible given that the Boars Head coastline has potential anti-Costi aster along almost the entire strip, and we don't want to introduce competition with an at-risk species. So our recommendation is to monitor the shoreline using citizen science. So this is an interpretive sign that we've created, and in the cutout section, so that will be cut out, and then an L bracket will be installed, and trail users can rest their phone on the L bracket, take photos of the shoreline, scan that QR code, and it uploads it to a Dropbox for the Nature Trust with a date and time. So that way the Nature Trust can get a slideshow of the coast, hopefully over the years. So this is what I was talking about earlier with the rare plants. The red markers are where we have found potential patches of anti-Costi aster, and the blue represents a 9-meter buffer. This is the estimated buffer we would need to reduce competition if we were replanting. As you can see, there's very little room for replanting, so that's why we chose not to go that way for coastal erosion. Extensive research on anti-Costi aster was done, and our team reached out to many contacts and experts of rare plants. However, the consensus was that genetic testing needs to be done to prove that this is anti-Costi aster. However, the Canadian Centre for DNA Barcoding database does not have enough genetic markers on this group of asters because of how recently they radiated. Given these expert opinions, we opted away from recommending genetic testing at this time of the plant and instead recommend monitoring of the rare species. As well, we did not find any maidenhair spleenwort. However, we do recommend to continue monitoring for it because it was found on the preserve fairly recently, and we were not at the best time of year to survey for it. To combat stream erosion, our recommendation is the phased planting of native species that can help stabilize stream banks and improve water quality. This will allow the ecosystem to adjust gradually and cause minimal disruption. We also recommend integrating stream garbage cleanup days into already planned volunteer days. This can foster community engagement and improve the visual and ecological quality of the streams. Lastly, we recommend a long-term monitoring plan that involves a macroinvertebrate survey to assess for APT and index. During our inventory, we did identify 2 notable invasive species, Japanese barberry and glossy buckthorn. Given the objectives of the client, prevention and early detection is the best recommendation for dealing with these invasive species. We recommend placing a boot brush station at the beginning of the trails with a sign encouraging trail users to clean their shoes and remind them of the risks of invasive species. We also recommend organizing a yearly BioBlitz where volunteers could use iNaturalist to identify species on the preserve, including potential invasives. The Nature Trust is not interested in intensive forest management, therefore we focused our recommendations on aspects of the forest that promote priorities that align with the client's objectives, such as snags and coarsewoody debris, which I'll mention later. The alder stand, however, does appear to be a Laurentian Acadian wet meadow shrub swamp, so we do recommend a proper wetland delineation for that stand, and the steps for that can be found in our report. And our other recommendation is to install bird and bat boxes within the alder stand. So snags are important for primary excavators and secondary cavity users. So we recommend maintaining over 27 snags per hectare in Boars Head Nature Preserve. Currently, there's over 100 per hectare in each stand. but we do recommend to conduct a monitoring survey every 5 years. And if there is a limit in snags, we recommend girdling trees, which is described further in our report. For coarse woody debris, it plays an important role in ecosystems, and it can be shelter and nesting sites for small mammals and amphibians. So we do recommend to continue monitoring this on the 5-year period, and these plots could be used for the Nature Trust for the snag and coarse woody debris surveys for the first 5-year period. We also recommend that hazard trees from the trails be left on the preserve to become coarse woody debris. Autonomous recording units, or ARUs, provide consistent, relatively affordable, and verifiable results. The client already has access to some and is interested in potentially using them. This could help us identify birds on the preserve, including any potential species at risk. The client expressed concerns over theft and canopy cover, so the recommended locations were placed using the canopy height map. So these are 2 recommended locations, and they are in areas with lower canopy because they are solar powered. A is for coastal birds and B is for forest birds. And the Nature Trust also identified the Canada warbler as a species of risk at interest. So the recommended forest bird ARU is located in the mixedwood stand adjacent to the wettest area of the preserve. It also has the highest percentage of ground vegetation. It is a suburban preserve, so it's not extremely likely that the Canada warbler would be there, but if it were to be at Boars Head, we think this is where it would be. Moving on to our coastal bird survey, even though we did recommend a place for a coastal bird ARU, we do think another option could be volunteer surveys using Merlin and walking along the coastal shore. This is because there's already a trail there, there's already access to the beach. Meanwhile, with the forest recommendation, it's in a bit of a sensitive area of the preserve, a wet area, and it's also in an area where we will be doing our trail restoration, so we'd like to keep volunteers out of there. Effective salamander conservation within the preserve requires a multifaceted approach. One of the key recommendations for salamander conservation aligns with our stream health and bank erosion recommendation. Our bank erosion recommendation will improve soil stabilization, reduce sedimentation, increase shade, and improve water quality, which will greatly benefit the salamander habitat. Maintaining coarse woody debris in the preserve also will positively impact the survival of salamanders as well as other wildlife. So lastly, we recommend ongoing monitoring of the salamander population following our methods from the fall. And now I'll turn it over to Annabelle to talk about our operations plan.
Our client has budgeted for 4 trips to the preserve per year, but we have found it feasible to split our recommendations into just 3 trips per year. We have opted for this more conservative option as it saves money and time and allows for a bit of wiggle room if something unexpected were to occur. We recommend that each of these monitoring tasks be done anywhere between annually to every 5 years, depending on the desires of the nature preserve or of the Nature Trust and the sufficiency of data. As you can see, several of these recommendations would only occur during the first year. This is the initial implementation of the operations plan, such as installing interpretive signage and updating our infrastructure. The next 5 years consist of monitoring and maintenance, which makes up the total of our 6-year plan. The tasks were divided so that the recommendations could be realistically completed in 1 day by the suggested number of staff and volunteers. We have compiled a list of all local legislation that we have found relevant to our operations plan. It is organized so that each act is attached to the associated recommendations, and we have also produced a list of actions that can be followed to ensure all legislation is abided by. For the sake of time, I will not go over our entire cost breakdown as it is extensive, but I would like to draw attention to our long-term cost breakdown. The darker colored gray rows represent one-time costs that will only occur during the first year of our management plan. The lighter gray represents costs that will occur repeatedly. The allotted budget for this project was roughly $9,000 per year. Given that our operations plan consists of 6 years, this equals roughly $50,000 for the whole 6-year plan. As you can see, the cost we've worked out is $49,398, which leaves a few thousand in wiggle room in case anything unexpected were to occur. To wrap up our presentation, I'd like to circle back to our objectives. Objectives that have been marked with a green check have been met, and objectives that we do not yet have insight on have been marked TBA. Out of our 7 environmental objectives, 4 have been met so far, and 3 will be reevaluated periodically following the initial implementation of the operations plan. Out of our 7 social objectives, 6 have been met so far, and the 1 objective remaining, TBA, aims to maintain above a 4.0 star rating on all trails, which will have to be checked regularly to monitor our progress. Finally, I would like to extend our thanks to all of our amazing profs who supported us throughout this project, and to our client for being so amazing to work with and helpful. We'd like to thank you all for taking time out of your day to attend our presentation. We have put countless hours into this project, and it means so much to us to have such amazing support. At this time, I'd like to invite the rest of our group up to answer some questions. We'd like to invite the first questions to be asked from our client, if you have any.
We don't have a specific time frame, like a specific year we could say per se, but it seems as though in the next, like by the next 10 years, it'll become an issue for the population of the shoreline.
And then in that case, if we lose them all to erosion, or we stop the erosion, do you have a recommendation for like an in-between intervention? That's a good question. I think that if the rate of erosion is continuing at the one that we measured, that if it was necessary to plant willows as a barrier in front of some remaining patches of Anticosti-aster, that way some could be saved.
Also, I think that if you were able to prove that it was Anticosti-aster, then that would open more funding options for mitigating erosion because of the rare plant species aspect.
That's great. Often a problem with small reserves is, they might contain a few things, it's nice and pretty, but is it functional? So any thoughts on, you've got one salamander sort of thing, Canada water, is there enough space for a breeding pair, population, viable, that sort of context of enough?
Yeah, based on my research of the Canada warbler, potentially not a large population, but it is feasible that it could be there. For instance, one of the studies I read said if it's over 300 meters from a busy road, then that increases the chance that a population would be there. And to preserve the center, like where the recommended ARU location is, that area is distanced enough from busy roads that potentially the center could be, though, yeah, it is pretty small, but for the Nature Trust species of interest, they're not interested in larger animals anyway, so I think that smaller animals like small vertebrates, salamanders, birds could potentially be using this preserve.
I have a question about the budget and the projected $9,000 a year. I just multiplied that across the 90 preserves with the Nature Trust stuff. Pardon? 93. So that's a stewardship budget of about $810,000. I was at a finance committee meeting yesterday, and that's not in the budget. So can you justify why, this preserve should take priority over others? Why that amount of budget should be allocated for this particular spot?
I think because it is one of the remaining natural areas in the very quickly developing area of St. John, that gives it some priority, as well the presence of listed species, which adds to the ecological value of the property, also contributes to that.
It's also quite a popular recreational spot, so the more that we can prioritize stewardship, I think the better in the long run.
Do you think there's any possibility because of the high human use there that the fundraising could be done targeted specifically to this reserve by people who are near it and use it?
I think that's a great idea.
It's very possible, yes.
Especially if partnering with the school for fundraising would be an option, that might be something that kids could take part in to become stewards of the land.
Yeah, that's something we'd hope to achieve at our town hall, get more people engaged in volunteering and donating for the preserve.
That's that. Thank you.
We're going to get started with the next presentation. Just want to say thank you to Boars. That was a great way to start off the morning. They did a great job. As we all know, an apple a day keeps a prof away. So next, I'd like to introduce the Happy Apple Acres Orchard Group with Allison Firesards presenting James Jackson and Ty Golden Duval.
Morning, everyone. I'd like to thank you for coming out today. I'd like to extend a great thanks to our client Elizabeth Hamilton and John for attending today as well. I'm James Jackson, Ty, and Allie, and we'll be presenting our stewardship plan for a Happy Apple Acres Orchard. To begin with, Happy Apple Acres Orchard is located in Douglas, New Brunswick. It is a family-owned operation by Elizabeth Hamilton and has been in the family since 1972. The property spans a total of 13.51 hectares, split into two sections, one being the apple orchards, and the other being the forested woodlot. To go over our project goals summary, we divvied them up into three main sections, being environmental, economic, and social. These really boil down to environmental conservation, so protecting avian habitat, maintaining watercourse health, and enhancing the forest diversity. Secondly, we looked at the orchard and woodlot resilience. So this is really revolving around implementing sustainable management practices to mitigate climate change and pest occurrences. Thirdly, we looked at the economic stability, as this is the primary business of our client. So this really revolves around prioritizing the ecological integrity of the property and enhancing the resiliency to potential economic losses. Lastly, we looked at community and recreation, as there is an established trail network on the property that is open to the public for walking. This really revolves around trail maintenance and expanding the current trail network on the property itself.
All right, so when we were designing the stewardship plan, there was three main categories of stakeholders we were considering: primary, secondary, and tertiary. At the primary level, we had the private property owner, Elizabeth Hamilton. Every goal, objective we created and recommendation was going to impact her, her business, her property, and her future. At the secondary level, we have the UNB Faculty of Forestry and Environmental Management and other adjacent orchards. UNB is up there as this property shares a boundary with Currie Mountain, and the client has expressed that there is concern there in being able to have a cohesive property that does not impact Currie Mountain negatively, as that property is important to her. And equally, we don't want to destroy the school's property either. With the adjacent orchards, there's three other orchards in the area, and naturally, given that there is business and economy involved, we don't want to be creating scenarios where pest and disease will be transferring in between each orchard. On top of that, Happy Apple Acres Orchards does have the only apiary in the area, so we want to be able to protect this primary source of pollinators. At the third level, we do have government at a provincial and local level, as policy and bylaws are always a consideration when making any kind of recommendation. So going through some of the results from our fall data collection here, we delineated the woodlot into three separate stands. The largest was the mixed wood stand at 7.44 hectares, and it was an intolerant mixed wood stand characterized by its large amount of balsam fir, followed by white birch and red spruce. This is a pretty young forest with a lot of mature, dead, dying trees for their age category, and this is really marked by that 22 centimeter DBH below, as we can see on the graph on the right. Moving down to that southeastern portion of the property, in purple here, we have the tolerant hardwood stand. This is the second largest stand at 2.8 hectares. We found about 458 stems per hectare, a little bit less than the 658 found in the mixed wood stand, with one more observed species at 13 observed species. This was characterized by a lot more mature tolerant hardwoods like red oak and sugar maple, with some white birch and white ash taking up a lot more space as well. As you can see on the diameter distribution, there is still a lot of distribution below the 22 centimeter diameter class. However, we see a little bit more even age range and distribution later in the larger species or larger distribution range. The final stand we had was the red pine plantation. This was planted about 40 years ago, and it characterized itself with 1,201 stems per hectare and 4 observed species. As you might imagine, it's a red pine plantation, so there was a lot of red pine here, but growing in the understory, there was white birch, balsam fir, and red spruce. Within our diameter distribution, we found the bulk of it was in between 22 and 26 centimeters DBH, with some right on the outskirts, and a lot of that smaller diameter distribution fell in with the white birch, balsam fir, and red spruce.
Moving forward with the apple orchard, we did a complete census of all 210 trees. There were 139 observed trees in the upper orchard and 71 trees in lower orchard. Upon visual inspection, we noted in the upper orchard 6 pest occurrences and defects, predominantly represented by mechanical browse by deer and fly speck. In the lower orchard, it was a bit more evenly spread between woolly apple aphid, russeting, and fly speck. We did a comprehensive soil analysis within the apple orchard, as there hasn't been one done in a fairly long time. Soil samples were taken and then sent off to PEI analytical laboratories, where they provided us with a soil health analysis. There were 4 notable deficiencies, being potassium, nitrogen, boron, and zinc. As well, they noted a phosphorus index of 3%. This is an agricultural tool to measure the potential nutrient loss through leaching and overland runoff, and a sub 1% value would be considered acceptable.
Okay, so I'm going to take us through some of the forecasting that was done for the woodlot section of the property. The reason that this forecasting was important to us is that we wanted to kind of see how species composition, general structure of the forest would change over time to influence our decisions. This was done over a 25-year timeline, broken up into 5-year chunks, and was conducted using open stand model for the Acadian forest region. In addition, all forecasting was done using a scenarios-based approach, meaning we had 4 defined scenarios, each with different levels of intervention, in order to showcase a range of options for the property and how that could impact the woodlot. So here you'll see a brief overview of the 4 scenarios that we considered. You'll notice that the tolerant hardwood stand is not included on here. This is because the topography in the area is quite steep. Therefore, we believed any sort of intervention would be unrealistic and possibly dangerous. So only the mixed wood stand and the red pine stand are included for each scenario. Scenario 1 is designed as a baseline to which to compare the other 3 scenarios. So you'll see that there is no removal or planting recommended. It is meant to describe how the stand would naturally succeed with no intervention whatsoever. Scenario 2 is a very light removal of 10% of trees by density. In the mixed wood stand, this will focus on the balsam fir and white birch in the stand, which are reaching the ends of their lifespan, and we want to try and capture some of that mortality and stop further blowdown on the property. In the red pine stand, this will focus on smaller diameter stems in order to try and encourage a new cohort of natural regeneration into the understory. Scenario 3 is just a step above Scenario 2 with a 20% removal by density. In the mixed wood stand, instead of just focusing on balsam fir and white birch, this will include a more expanded species list in order to evenly distribute or more evenly distribute the removal across all the species in the stand. This will also include the opportunity for fill planting in this example of red oak and white pine in order to explore how planting desired species might impact the regeneration and control it rather than leaving it natural.
Scenario 4, as you'll see in the mixed wood stand, is the highest removal of 30% by density, also with an expanded species list, but with no fill planting, in order to explore how this 30% removal will impact the natural regeneration and allow trees to succeed without planting. In the red pine stand, however, we wanted to explore a full removal of this chunk of the trees that have been growing for 40 years and completely plant the area, in this example with white pine and eastern hemlock, in order to showcase how the client could change this property to better suit her needs. Okay, so before I get into the results, I'd like to go over what results you're going to see. So the first metric will be species composition, in which we're going to look at what species will decline over time and what the dominant species will be predicted to be in 25 years, as well as within each 5-year chunk of time. So here you'll see the mixed wood stand species composition. All of the graphs that you're going to see will be one graph per scenario. So here you'll see scenario 1 and scenario 4. This is our no intervention and our highest intervention, in order to give you an idea how both of those will impact the forest before we narrow into the more middle scenarios with 2 and 3. So you'll see here in scenario 1, each bar is representing a 5-year time span, and then covers the whole 25-year period with them all added together. And you can see how from period 0 to period 4, we are expected to lose quite a bit of the balsam fir in the stand and gain quite a bit of red spruce in its place. As you can see, the balsam fir is the light green at the bottom, and the red spruce is the pink sort of in the middle. In comparison with our highest intervention in scenario 4, you can see a much more dramatic loss of that balsam fir in the light green, and in tandem, a much higher increase in the red spruce. This is paired with a loss of some of the less abundant species in the stand, such as the red oak in red and the white cedar in the darker blue. Now we're going to narrow into scenarios 2 and 3, which, if you remember, are the 10% and 20% removal. The scenario 3 including the possibility for fill planting. Scenario 2, the main difference from scenario 1 with this 10% removal is that we didn't see the same predicted increase in red spruce. As you can see, there's not the big chunk of the light pink in the center. However, we still did see the decline in balsam fir. Scenario 3 is where we implemented fill planting, so you can see that reflected in planting period 1, where you can see the large chunk of red oak and the gray of white pine. Okay, we're going to move into our next metric for this forecasting, which is diameter distribution. For this, we really want to see what size trees will be dominant in the future to try and get a picture of what the overall structure of the forest will look like. We also want to see how regeneration will change across time. Now, these two figures at the bottom show us kind of what we're looking for in terms of shape when we're looking at these graphs. So we'd like to see if the distribution from small on the left to larger trees on the right is more heavily skewed towards the smaller trees, or if it's more skewed towards the larger trees, as you can see in the figure on the right. Starting off again with scenarios 1 and 4, we didn't see a whole lot of change in terms of overall shape of the diameter distribution in scenario 1, which again is no intervention. However, there is a predicted steady increase in regeneration, which in this case refers to trees under a 10-centimeter diameter. Scenario 4, you do see quite a bit of a change in the shape of that distribution, with a lot more trees focused towards the larger diameter end throughout each planting period. You also see a much steeper increase in regeneration over time as we take out the trees in the overstory and let the understory succeed. Narrowing back down into scenario 2 and 3 in the mixed wood stand, there was not a significant difference with scenario 2, as it is a very light, only 10% removal. However, in scenario 3, you can see how that fill planting really impacted the structure, with, in period 4, a large spike in the smaller trees when all of these planted trees move into the 10-centimeter and 12-centimeter diameter classes. You also see a much higher regeneration, which is to be expected with the trees artificially planted. Okay, we're going to go right into the red pine stand from there. So this is species composition again for scenarios 1 and 4. In scenario 1, as to be expected, the dominant species is red pine throughout. The only real change we see over time is the loss of the red spruce in the understory by planting period 4. Scenario 4, as we discussed, is much different from scenario 1, since it does involve a removal of all these trees that were already there and a planting of desired species. In this case, the eastern hemlock, which is the yellow at the bottom, and the white pine, which is the gray towards the top. Narrowing into scenarios 2 and 3, we don't see much of a change between scenario 1 and scenario 2, except we do manage to keep some of that red spruce around towards the end of the planning horizon. If you see in scenario 3, we have that presence of red oak in red and white pine in gray in the planning periods 0 and 1. However, we do lose all of that regeneration by the end of the horizon. Okay, and diameter distribution, we're going to start off with only scenario 1 because as the host stand is removed in scenario 4, there isn't anything to look at in terms of data here. So in scenario 1, you can see, again, not a huge change in structure over time, and we have much lower regeneration than observed in the mixed wood stand. Scenario 2 and 3, like the mixed wood stand, we don't see a huge difference between scenario 1 and scenario 2 with such a light intervention. However, in scenario 3, the main difference you'll see is the amount of regeneration. This is to be expected as the planted species are inflating that number. Okay, and to finish up the forecasting, we're going to talk about the tolerant hardwood stand, which, as discussed before, was only forecasted for scenario 1, which is the no intervention scenario. You can see the main change that we're expected to see in the tolerant hardwood stand is this decrease in sugar maple over time. Sugar maple is the bright green sort of in the center, and an increase of white pine over time, which is the light gray towards the top. Now, diameter distribution in this stand is, again, not expected to change too much over time. However, we do see quite an increase in regeneration in the understory.
Okay, so with all the forecasting done and in mind, we wanted to make a plan going forward that was accessible for the client, and we broke it down into 2 sections, a 5-year operation plan for the woodlot and the apple orchard, and a 25-year monitoring plan. For the woodlot in the 5-year operational plan, we decided to recommend scenarios 2 and 3 with a 10 to 20% removal by density. Ideally, this was built for it to be a little bit fluid. Maybe the first goal will be to focus on scenario 2, try to get some of the mature, dead, and dying balsam fir out of that mixed wood stand to kind of encourage some new growth. But if the assets are in place, scenario 3 is very viable in terms of also reaching those goals and encouraging a maybe faster split of diversity. One thing we would like to recommend with this too is that the client try to keep 8 large diameter snags per hectare. This should be feasible with the metrics we collected, as there's plenty of snags within the mixed wood stand. Moving forward, we also spoke with the client at the beginning of the year, and they had asked about possibly mapping out a trail they'd like at that northern section, that green trail. This trail should be roughly about 415 meters, and given their goals and the way this property works, the trees cut for this trail can go towards the annual allowable cut. The trail does cross 2 streams, one permanent stream and an intermittent stream. For the best course of action, we do recommend a footbridge be put in place to kind of protect the ecology of that area. This will require a WAWA permit by provincial legislation, and we think the most cost-effective way to do this is to use a saw log that has been cut while clearing the trail, cut in half, and laid across the stream. The apple orchard has a couple more moving parts with our recommendations. As we mentioned, one of our goals was to enhance and protect avian habitat. However, another byproduct goal was to kind of maybe reduce the amount of pesticides, herbicides, and fungicides being used within the orchard. One way we thought we could do this is by establishing 1 artificial perch for forest raptors in the upper orchard. This is close to the 2 forest raptor nests we have found on the property, and research has shown that it is a great way to enhance and encourage raptors to hunt within the orchard. The client, if they please, can put another in the lower orchard, and that would be exciting. However, it does not necessarily mean more forest raptors will be using that area. Moving more towards the ecological enhancement side of things, one way we wanted to again encourage that reduction of use of pesticides, herbicides, and fungicides was through companion planting. Companion planting is a permaculture theory where you plant species of plants together that have some sort of mutually beneficial relationship. Within the apple orchard, the 2 main ones we're going to recommend are chives and red osier dogwood. Chives help deter apple scab and help deter deer, while red osier dogwood helps promote and bring insects that like to hunt the insects that are harmful to apple orchards. Chives can just be planted near and around the apple trees, while red osier dogwood, we only need 1 or 2 per stand or per orchard. About halfway through the fall, our client brought up that there was a blueberry patch on the property as well that they'd like us to investigate and make recommendations for. And with that, we, through our investigation, are also going to recommend companion planting. The main one we're recommending for the blueberry patch is wild strawberry, as it helps us keep the soil acidic, which is very important for blueberry patches and something blueberry patches can struggle with. Very similar to the apple orchard, wild strawberry can be planted in between the rows of the blueberry patch, and within a few years you'll have yield of berries from that as well. With the blueberry patch, we're also going to recommend that annual tending be done to it via pruning branches with lower yield. The final part of the apple orchard that we're going to recommend for the first 5 years is to act on the soil health analysis we did and take a look at the two main nutrient deficiencies we saw in potassium and nitrogen. And what we're recommending there is the application of a potassium nitrate fertilizer, 250 kilograms per hectare, and that will be done twice in the wet season, preferably May and June. The only restriction we have there is that due to that high phosphorus index that we mentioned, to be careful about over-applying and making sure it gets spread out evenly, as it can cause burning to the herbaceous species in the area.
Okay, moving forward with the 25-year operational plan, it is a bit more broad than the 5-year operational plan and heavily focuses around two main aspects, being invasive species monitoring and a bit of property maintenance. Beginning with invasive species monitoring, this will be focused heavily on invasive herbaceous plants within the woodlot, and will be observed through transect walks and a property boundary walk. As you can see here, there are some proposed transects. They're to be no less than 100 meters in length and no less than 100 meters from each other, excluding transect number 2, which connects the endpoint of transect 1 and the start point of transect 2 together. With this, any identified herbaceous plants should be removed immediately in the manner most befitting that plant or deemed by the client. Furthermore, just a bit of property maintenance will be culvert remediation. There are 3 culverts located along stream section 1, and all 3 culverts exhibit about 18 inches of perching, which under the New Brunswick Wawa Act acts as a barrier to aquatic species movement. There are 2 ways that this can be completed, one through a tailwater control structure, which is effectively a riprap weir, using 15 to 20 tons of R5 riprap and about 15 to 20 square meters of filter fabric to control sedimentation. This is a one and done kind of operation and can be completed for about $1,000 plus tax installed per culvert. Secondly, a more laborious method and requires more constant maintenance would be the construction of stepping pools, which would involve felling trees into the stream downstream of the culverts, raising the water level by no more than 8 inches at a time to gradually increase that water depth up to the culvert itself. Both of these would require a Wawa permit to comply with provincial legislation. To help make this a bit easier to implement for our client, we are providing her with numerous resources to include, but not limited to, the New Brunswick Invasive Species Guide, ongoing monitoring forms for trail assessments and the woodlot and invasive species, stick nest identification keys, as well as links to all applicable acts and legislation through CANLI. Through this plan, providing kind of a dynamic range for operating within the woodlot, installing raptor perches, and remediating the stream bodies around the culverts. We feel that this plan actually hits all of our objectives in all 3 categories, and through implementation of this should prolong the longevity and health of her property. We'd like to extend a great thank you to our client, Elizabeth Hamilton, her friend John, and all of you for taking the time out of your day to view our presentation. And we'd like to open the floor up to questions, invite our group up, and extend the first question to our client.
And of course, it affects the shape of the stream, particularly when you have an artificial culvert in the middle. So I really appreciated the work that you just presented on culvert options, ways to make culverts work better, and to preserve the stream bed in a way that's more beneficial in a sustainable sort of long-term approach. One thing that I had talked to you quite a bit about in Harvard was the reason, one of the main reasons for this study, which was the juxtaposition of our property to Currie Mountain. Currie Mountain is a provincial, from the university, in that it has a lot to offer citizens. And because we bought the property, what we do on our property influences Currie Mountain and vice versa. So if you were to put on an extra paragraph in this final report, it would be something to the effect of, for the property owner to keep abreast of what's going on with Currie Mountain's management plan. That I can't put it any other way except to say, ForEM fauna don't respect the written word for legislation. They don't read. So what we do affects Currie Mountain, what Currie Mountain does affects us. The last thing I'd like to see is for our property to be turned into a development subdivision. So I think you've given me some good tools and given some good operational tools. And I really thank you for the delight it brought to the orchard while introducing me to all sorts of things I just didn't see. The last is not a question, and I know I'm not supposed to, participate as I presented, but the bit on insects is, I think, a little understated, and that's because of the time frame of this study. Our worst predators, our worst pests are maggot, falling off, butterfly, and now butterfly. So I look forward to reading the report to see whether some of those issues, and those are the ones that we do require us to use pesticides more often than not. I'd like, if I could read the report and see what has been done. Oh, they have no questions. I'll sit down now. Thank you.
Thanks, Elizabeth.
Kevin, go ahead, you go ahead.
Yeah, so you're gonna cut a portion of the lot, like when you, the 10%, 20%, 30%. Were you planning to do that with forestry machines, or were you just planning to go with a chainsaw?
So that's a great question. There was a lot of options we explored there, and I think given we met with Ann McKnight from the YSC to kind of discuss those options too, and given the topography, the location, the size, and some of the restrictions, if you saw that with the streams and the wetlands, it would require a lot of very small scale forestry equipment, and it just with what the market is and how people contract out, that's probably not going to be the most feasible route. So in our report, we discuss alternative options, but it'll likely be with small felling equipment, like just by hand with chainsaws, drug out with like a tractor or a quad or something, or whatever that could look like.
What was the planning horizon here?
Oh, sorry, I know I glanced over that. It was a 25-year period total, broken up into 5-year chunks. Period.
25-year planning horizon. I almost thought we referred to that as a strategic plan. How come you got referred to it as an operational plan these days?
So the operational plan was the 5-year plan, and that's where a lot of the actionable items will be taking place. And the 25-year plan is more for monitoring and ideally to see how that 5-year operational plan works out. And the way we design the 5-year operational plan is that it can be placed, kind of repeated in the future and altered as necessary with proper monitoring.
Yeah, so the strategic plan, of course, is for your long-term objectives. I just thought I saw there on one of the last slides, 25-year operational plan. I'm not sure that was.
Oh, that might have been a miswritten something. Yeah.
Sorry.
Okay, well, what about, you guys had 5 management scenarios, 4 or 5 management scenarios for the board to do. What was the objective there?
the objective with that was mainly to inform the client of what the potential of the woodlot could be and what that could look like if they were going to pursue different options. And in the 5-year operational plan, in the actual report, we give a little bit more detail on what each would look like and what actions you would want to take to kind of pursue that. And it was to help us justify to the client why we're going to recommend scenario 2 and 3, let's say, and see how that compares to the other scenarios. Sure.
Well, then, in that case, what would be, if you, to have this general objective, what were the indicators that you're using to measure the success of these different scenarios? What would be the main indicators you're looking at?
Yeah, sure, that's a great question. So the main one, as the client mentioned, is Currie Mountain is very important. So we wanted to make sure that there was some sort of metric there that was not necessarily combining the two properties, but allowing them to exist in a healthy way and mitigate any kind of pest and disease that could be occurring within the woodlot, but also still be accessible and obtainable in terms of actually having it be actionable. As I mentioned to Gavin, the harvesting restrictions on this property are very many. So that was one thing we considered there as well, but a lot of it was also under the idea of trying to kind of encourage and build an uneven stage structure. So that's what we looked a lot in our forecasting was what will maintain that kind of biodiversity split and help encourage a better succession in the forest stand. And that's part of why we didn't recommend anything with a tolerant hardwood stand, is it was already there. The mixed wood stand, as I mentioned, was a lot of balsam fir, white birch, and red spruce, and there's a fair amount of it kind of at the end of its life, and there's a fair amount that's suppressed, and there's even some blowdown in there. So a lot of it is to kind of repair and start enhancing that so that it can, and especially that's the part of the property that borders Currie Mountain the most, so that's where we were going with that. I hope that makes sense.
Yeah, that's good. And just one last question. Although you guys did speak a lot about diameter distribution, so I would say that would be an indicator we should look at.
Yeah.
In the stand simulation model, how does it go about estimating regeneration?
Well, when I put it in as regeneration, like I said, that was any of our trees that were spit out as below 10 centimeter diameter, because that's when we did our inventory, we tallied like our small tree below 10 centimeters and our large tree above 10 centimeters. So that was just me going in and sorting out the trees from below 10 centimeters into that one category.
Well, one thing you may want to consider that as a limitation with all the settings and models is it actually doesn't have the capacity to do regeneration. And so, of course, when you're using it to study something like composition, like you do, knowing something about regeneration is pretty important. So, when making those forecasts or making those statements, that's an important maybe aspect to bring up the limitations of what you can say. Good job.
Ben?
So as you mentioned many times, you want to be kind of coexisting with Currie Mountain. In this ideal scenario, what would you like to see from the universities that manage Currie Mountain kind of do at a similar rate with your guys' project to kind of have that coexistence and see the overall forest health and like as your client said, like they are really pretty close to like together. So animals go back and forth, pests go back and forth. So ultimately, what would you like to see Currie Mountain do at a similar time to assure that your guys' scenarios are a success?
I think a big thing that the client brought up to us was a concern about the use of the property like from the public. So I think things sort of like awareness on fire safety, having campfires on Currie Mountain, I know that was a concern because that is something that directly impacts, the trail system use on Currie Mountain kind of directly connects to the trail system in our client's property. So I think more awareness in the social department on how to respectfully use the trail system would be beneficial.
Go ahead.
We had had some discussions over the year about the changing political and the economic environment. And I was pleased this morning that you had mentioned sourcing nutrients for the orchard from Canada. Obviously, much of what we do with this plan will be governed by availability of products that we use to protect the orchard and ensure the crop. So I was pleased that you have done that research ahead of time. Thank you very much. But it also makes it clear that the discussions we had will be ongoing. Many of our clients are from the States for pest management. So thank you for that.
Brilliant.
I have a question about the red pine plantation, and like, is the overall objective to like phase that out over time, or convert it into something else?
Yeah, so that was something we talked about with the client a fair bit. That is kind of it, where it's not being used for any, it hasn't had any intervention. I might have skipped over that in the results. It hasn't had any intervention within the 40 years since it's been planted, so there is that kind of, what we're seeing is that late stage part where a lot of it is not starting to collapse, but the crowns are starting to outgrow the stems and crowd out the rest of the area. So given the objective, the idea is, yes, that over time and with further details in going through scenario 2 and 3, the idea is that, yes, the red pine plantation will kind of be phased out over time and more integrated naturally.
What, like, do you know what's the average lifespan of a red pine? At what point would it be?
From a forester or without any intervention?
Oh.
I mean, at a harvesting level, typically I feel like you're looking at 68 to 80 years, but red pine can be up over 100, right? We're probably taking a more active role in that some of it will be cut, and the idea is that the mixed wood stand surrounding the area, or if they use scenario 3, there'll be some underplanting to kind of encourage the species coming up instead.
Okay. So I didn't catch it, but did you settle on one scenario as the first scenario for that stand?
Yeah, so overall, we're recommending scenario 2 and 3 for the mixed wood and the red pine plantation as a whole. And they were forecasted separately, but the recommendations are being kind of done in one. And the idea is, yes, that they'll be the main recommendation is scenario 2, but there is fluidity to go up to scenario 3, and it won't necessarily impact the outcomes of either or too much.
Okay. Yeah, like when I saw scenario 4, it's just like kind of how plant white pine, I immediately thought you're going to have pine weevil issues.
Yeah.
I've got a lot of people pine for that.
Yeah, and that's kind of what I was saying to Dr. Taylor earlier there, where part of scenario 4 was to just kind of inform the client on what is possible, even though there is never really a scenario here where the red pine plantation would be completely cut. As Elizabeth mentioned to us when we were talking about scenarios, there's a red fox that lives in the red pine plantation, and we don't want to take that habitat away from it. The goal was just to kind of see what would happen, and yes, we did recommend planting white pine, but we also recommended the planting of eastern hemlock, and part of that was to, one, mimic the Currie mountain setting of that kind of, obviously it's not going to be mature white pine or eastern hemlock for quite a while, but to kind of encourage that growth. But also because, through my experience, I'm not saying there's any scientific research behind this, but with the foresters I have worked with, eastern hemlock has been proven to be a very great cover crop for white pine. And there's been a lot of success, especially once both of them get past that 2-meter height, where they start to really grow together and complement each other.
Did you look at aerial photography going back through time? Because I think it would be really interesting to know what was there prior to the 1970s. Whether it was a field. I've done aerial photography back in 1944 on our property, and it's cool to see that. But it may give some clues as to what suitability might be.
I think we did look at aerial photography, and we didn't look at it too seriously. A lot of it was to kind of see what the orchard looked like historically, and there was 1 or 2 aggregate pits on the property as well, and we kind of wanted to see what was going on there.
Okay. Yeah, I would recommend that any 40/20 group would try to learn the history of the property and find out what was there before. I'd come up with some interesting surprises, but also clues as to what nature wants to out there. Okay, thanks.
You managed to find one property, right, one property, or 2 properties in March, in this property, in terms of, I don't know,
I would say things like invasive species and pests, as you said, as this is the orchard, like there's an orchard component, we want to really watch any possible pests that could be impacting the orchard. And as there is a lot of concern about the Currie Mountain property and the health of that, because there, of course, isn't a clear boundary, things like invasives and watching out for that and controlling that spread from adjacent properties, I think would be one of the main indicators of priority.
And to build on Ali's answer there, there's a few specific invasive species too that we want to be careful and cautious for, and Elizabeth mentioned it earlier, where one is fire blight, and that's been a large concern within the apple orchards of New Brunswick. From what I understand is there hasn't been any, it hasn't been spotted or known in that area, so that's part of the monitoring plan, is keeping an eye out for that. And something we recommended in our final draft, or final report that we didn't put in here, is to pay attention for some of the for species like showy mountain ash that are known for being conduits for that pest and disease, and to have that removed. And we gave a whole identification guide for that tree. Yes.
Okay, welcome back, everyone. Thank you to the members of the Elizabeth Hamilton project. That was awesome. We are going to introduce our next project, which is the Ducks Unlimited project, and I'd like to invite Emma, Taylor, and Sarah here now.
Alrighty. Good morning, everyone, and welcome to our presentation on the Nashwaaksis Stream Nature Park. My name is Taylor, this is Sarah and Emma, and we will be presenting our management plan. First off, we would like to do a land acknowledgement. We respectfully acknowledge that UNB and the Nashwaaksis Stream Nature Park stands on the unsurrendered and unceded traditional Wolastoq land. The lands of the Wabanaki people are recognized in a series of peace and friendship treaties to establish an ongoing relationship of peace, friendship, and mutual respect between equal nations. Now, please meet our team. We consist of 10 students in the environmental management faculty, ranging across all 3 majors. For our agenda today, I'm going to start us off with a site introduction to talk about the characteristics of our property, the historical background, and the goals and objectives of our project. I'll then leave this with Sarah to talk about our wetland management and water quality management. Emma will take over with the wildlife management and public engagement and education, and I will finalize our project with the financial summary and closing remarks. So about the property, our client, Ducks Unlimited Canada, signed a conservation agreement with the City of Fredericton in 2007. And about the location, so the map above represents the Nashwaaksis Stream Nature Park, and the pink dots at the top of the site represents the culverts that come into the site. And the middlemost culvert is the inlet, where all the stormwater drains into the wetland, filters through the wetland, and leaves at the outlet, which is at the bottom of our site. There's also a boardwalk with a viewing platform, and the park is used by the public for recreation use. And the City of Fredericton has a snow dump along the bottom right corner of our property here. So a little bit more about our property. There is a trail that goes along the dotted line of our property. And I also want to say something about the site characteristics. So the light green on our property represents the forested wetland. And the middlemost portion is our main shrub wetland. And that consists of the emergent marsh, meadow marsh, and open water characteristics. And the top right part is our secondary shrub wetland, which has the emergent marsh and open water. And this is our boardwalk, and the boardwalk looks over the main shrub wetland. And the Clemson leveler, so we collected our baseline data prior to the implementation of the new water infrastructure, which was put in this previous November in 2024. The water infrastructure is the Clemson leveler and the rock spillway, and this is to increase water retention on the property. And this is a picture of the Wolastoq and St. John River, and that leads into the Nashwaaksis stream that goes along the outer edge of our property.
So historic background, there was a lot of really neat information that we found in the archives. And the top map in 1931 represents the original imagery for our site. And as you can see, it was very much farmland, very little urbanization of the property. And when you go down to 1975, you can start to see more urbanization, more trees. And the most recent imagery is from 2023. And the only change to that, to what we have today, is the new water infrastructure. So for changes over time, in 1997, this is when the city of Fredericton purchased the property. And in 2007, as I've stated, this is when the conservation agreement came into play. And in 2024, this is when the new water infrastructure was put in. For our goals, so we have 4 goals for our project, and that is to maintain the ecological integrity, to establish a long-term wetland monitoring strategy, to offset water control management costs and impacts, and finally, to improve the public awareness. For our objectives, we have 15 objectives that I'm going to try to summarize for us today, and that is to protect area of suitable breeding habitat for at-risk bird species and painted and snapping turtles, to maintain current distribution of monarch butterfly habitat and endangered and rare plants, to maintain diversity of wetland types, increase wetland functionality over time, to maintain soil and water quality over time, and to reduce negative impacts of non-designated trails. To continue, we want to maintain consistent data and sampling approaches, to produce a baseline data collection strategy for long-term monitoring, to reduce chances of severe floods in nearby communities, to ensure all culverts are compliant with provincial standards, and finally, to improve the public education on native wildlife and plant species and water control infrastructure. I will now pass this on to Sarah to talk about our wetland management.
Thank you, Taylor. So we will get into the wetland management. First, we will start with hydrology. With hydrology, it is predicted that the water levels will increase after the installation of that Clemson leveler. You can see the Clemson leveler in this picture as that little gray box down in that second photo. This 0.28 meters, that change will change the depth to water table as seen on the map. The darker blues represent water closest to the surface, while the lighter blues represent water that is deepest below the surface. This 0.28 meter water increase will influence management decisions, recommendations, and subhabitat shifting. The site is a natural river floodplain, therefore the natural features depend on that seasonal flooding. The property floods every year. However, that is predicted to decrease due to the 5 to 10% decrease in annual snowfall per decade by 2050. The risks from flooding are threats to infrastructure such as the Clemson leveler, the boardwalk, the trails, and the culverts. The other risks is that flooding could lead to the spread of chemicals by leaching from stormwater and the snow dump. There is a history of high flooding in the Fredericton area. The map over here with all those beautiful colors describes what varying flood levels will look like on the site. 6 meters in pink to 6.5 meters into green is the level when floodwaters would start to impact residents. Anything above 6.5 meters would be considered a major flood, which could cause damage to the man-made structures on the property. An 8 meter or more flood would reach the snow dump, which could lead to leaching. The snow dump, that point on the snow dump can be seen with the yellow and the brown in the map. It's important to note, though, that these historical levels have occurred on the site. And that map over there with the Fredericton historical max flood levels shows that that has happened in the past. This map here shows the current subhabitats and how they will shift post-Clemson leveler. Shifts in habitat can impact wildlife, vegetation, and wetland features on the site. The forest habitat, which is represented by that lighter green, will decrease by about 17%, while the meadow marsh, represented by that darker greenish-brownish color, will decrease by 2%. The open water habitat, although in that darker blue, will increase by 163% after the Clemson leveler is inputted. Then the emergent marsh habitat, which is that lighter blue, will increase by about 160%. These areas on our site will be the largest change that will cause huge places to make decisions, recommendations. We identified 6 rare and endangered plant species on the site. They are hopsedge, American elm, butternut, green ash, and white cut grass. These rare and endangered plants are vulnerable to habitat change and pressure from invasive species, and the rising water levels could alter their habitat. The recommendations are to annually monitor the site and health of these presence of these species, and to maintain that existing 30-meter wetland buffer, and to apply restoration planting where needed. We then went on and identified 6 invasive species on the property and 1 problematic species. These 6 invasives are glossy buckthorn, wild angelica, reed canary grass, purple loosestrife, bittersweet nightshade, and common burdock. That problematic species is the broadleaf cattail. With a water level increase, this will influence the future presence of these species. It will likely increase the presence of broadleaf cattail, creating a dense monoculture that is unbeneficial for the site's diversity. It will also likely increase the spread of glossy buckthorn and common burdock, yet it may reduce the presence of other invasives due to a decrease in suitable habitat. The recommendations for this issue will be annual monitoring to detect their presence early on, as well as low-intensity removal by hand pulling and cutting, and replanting those removal sites with native species. We assessed 3 large trails on the property to determine their impact. These trails are predominantly used for city maintenance, such as garbage removal. Maintaining some access to the site is very important for the City of Fredericton, but is not a high priority for our client, as unmarked trails allow for public access into vulnerable habitats. The assessed trails are A, B, and C. A is in the top corner, while B and C are those trails towards the other side. B is the shorter one, C is the longer one. C is a predominantly degraded trail, and this is a priority for remediation. And B as well also has parts that need to be remediated, as well as small parts of A. There are 3 possible scenarios for the trail system. Scenario 1 recommends a full restoration of all trails by planting native species. This scenario also prevents further access into the property by vehicle. Scenario 2 recommends a partial restoration. The process of restoration would be over a 3-year time period. Every year, 1 trail would be restored. This would allow for partial vehicle access into the property for maintenance. Like Scenario 1, the restoration will be done by planting native species. Scenario 3 recommends status quo, therefore no restoration of trails. However, it is encouraged to reduce trail use during wet periods to minimize rutting. For native planting, we are recommending to plant 18 native species. The process recommended for this planting will be to source trees and shrubs from internal Ducks Unlimited sources, as well as sourcing vegetation from other Ducks Unlimited sites, and as well use stem propagation for various shrub species. The areas where planting is suggested are the areas where invasive species are being removed. That can be seen in those 2 red dots. Those are some true hotspots where we will be suggesting to remove those invasive species, as well as those 2 trails, yellow and red on the map. That is trails B and C, as well as areas where there is high human disturbance on the site. The snow dump is located within the 30-meter buffer of the wetland. This impacts the health of the site when sediment and chemical runoff goes into that wetland from the snow dump. High sodium and chemicals such as mercury and arsenic also pose a risk to the health of the wetland. It is recommended that straw bales are placed along the border of where the snow dump and the wetland meet to reduce the chances of that runoff entering into the wetland. It is also important to educate snow dump users about the impacts of runoff. Next, we're going to go into water quality management. Water quality was assessed at both the inlet and the outlet of the wetland. The results showed that chromium, zinc, and manganese surpassed threshold levels for aquatic life. It's predicted that water levels increasing will create longer anaerobic conditions. The longer lasting water will result in less fluctuations between wet and dry periods, which will result in less chemicals being released from the sediment. There is also the potential for chemicals like iron and manganese to be released due to redox reactions, and a potential for increases in mercury and dissolved oxygen due to plant decomposition. we recommend implementing a water quality monitoring plan that includes water quality samples at the inlet and the outlet, as well as YSI readings. Water filtration can be done through a process called phytoremediation. Phytoremediation is when plants filter excess chemicals from water and soil. Chromium, zinc, and manganese are the current metals of concern at the site. The recommended species for remediating these chemicals are broadleaf cattail, common duckweed and pondweed, and various species of sedges, rushes, and grasses. It is important to note, though, that previously stated, broadleaf cattail is a problematic species. Therefore, we do not recommend planting it, but we do recognize that it is a species that has the opportunity to uptake those 3 major chemicals currently at this time. Next, I'm going to hand it over to Emma to go through our wetland management, or wildlife management.
All right, I'll begin our wildlife management by discussing the mammals that we found on our site. We identified 3 small mammals, the northern short-tailed shrew, the eastern meadow vole, and the white-footed mouse. Small mammals act as primary seed dispersers, as well as indicators of the general environmental condition and prey species for the larger mammals seen on our property. We have identified 3 large mammals on the property. White-tailed deer have been observed using the property as bedding habitat, as the image there shows, as well as American red fox have used the habitat in the winter for hunting, and common raccoons have been observed year-round as they are generalist species. Large mammals are important as they help to maintain and manage the small mammal population within our property, as well as increasing and maintaining the general biodiversity. Our recommendations include annual small mammal surveys to identify how the small mammals are adapting to the change in the habitat, as well as presence and absence surveys, the use of game cameras to identify large mammal communities within the property. Our wetland birds and waterfowl, we unfortunately were not able to sample properly for wetland birds and waterfowl. However, with the predicted habitat change, there will be an increase in cattails and floating and emergent vegetation, which will facilitate breeding habitat for species such as the least bittern, which is a species at risk, as well as increased habitat for cattail wetland specialists such as the Canada goose, the sora, which is featured there, and the mallard. Within our forested wetland, the predicted habitat change will increase available habitat for cavity nesting duck species, such as the wood duck, which is featured there as well, the common goldeneye, and the hooded merganser, which we did observe in the Nashwaaksis stream in the fall. Our recommendations for wetland birds and waterfowl include the restoration of the current duck boxes that are located along the Nashwaaksis stream, as well as the installation of 2 new duck boxes, one within the main shrub wetland and one within the secondary shrub wetland to facilitate breeding within the open water habitats. We also recommend biannual point count surveys to be conducted, one in the summer during migratory season to determine what migratory birds are using the property, as well as one in the winter to determine bird usage during non-breeding seasons. Aerial insectivores are set to increase. There will be an increase in standing water. Therefore, there will be increased habitat for flying insects such as mosquitoes. These act as the primary feeding habitat for species such as swallows, swifts, and bats, who are currently facing global population declines. Our recommendations include the installation of bat roosts to facilitate bat breeding on the site, as well as monitoring the site for inhabitants, which can be done doing nest box checks on the site, as well as point count surveys. At the base of our property here, you can see that we have a significant patch of common milkweed. Common milkweed acts as the main habitat type for monarch butterflies. Monarch butterflies are a listed species. It is important to note that with the water level rise, we do not predict a threat will be posed to the common milkweed. Therefore, our recommendations are to protect the current 300 meters squared distribution of the milkweed at the base of the property by avoiding cutting within the area by the city workers. Pollard walking sampling method should also be conducted bi-weekly during the breeding seasons in the summer to determine abundance of the property. Educational signage should be installed to inform the public of the habitat use via these rare species. With the predicted water level increase, there will be potential habitat for species such as the common snapping turtle and the eastern painted turtle. There's predicted to be habitat for 1 male snapping turtle or a breeding pair. and enough habitat for 50 or more eastern painted turtles. Both species feed primarily on benthic macroinvertebrates, fish, and aquatic and emergent vegetation. Therefore, our recommendations are to perform annual benthic macroinvertebrate and kick netting surveys to identify prey populations within the open water, as well as the installation of basking logs to minimize basking log competition between eastern painted turtles. We propose the installation of 3 basking logs, 2 within the main shrub wetland and 1 within the secondary shrub wetland. Educational signage should be installed once turtles have been observed on the site to inform the public of nesting habitat. Lastly, I'd like to finish this off with fish. There is not currently a fish habitat within our site. However, with the stabilization of the water table, this will create potential fish habitat for species such as the banded killifish, sticklebacks, minnows, yellow perch, and American eels. Visual surveys should be conducted over the first 5 years to identify if fish have entered the wetland and whether they are there. Hobo loggers should also be installed to track the hydro period, which determines the water level and the water temperature over different times of the year, which can help identify how fish will react if they get stranded within the wetland. Once fish have been determined, baited minnow traps can be used to identify species type and abundance within the property. It is also important to note that the Clemson leveler can act as a barrier to fish migration, as fish will enter the wetland during flooding seasons and potentially become stuck within the wetland. So performing surveys before and after the leveler in location to determine how fish react to the leveler will be important. We next have our public education and engagement. I don't know if you can see, but this is just an image of the site in correlation to the rest of the Fredericton trail systems. We identified 4 main stakeholders within this project: the St. Mary's First Nation, the City of Fredericton, the local ENGOs, as well as the locally affected public within the area. This table identifies the influence that these stakeholders hold on the project, as well as the stake that they have within our project. We recommend 3 main things to engage with stakeholders, organized events such as bird surveys, organized meetings between multiple stakeholder groups, and the implementation of new educational signage. Sign options and examples could include stormwater retention benefits, the ecological importance of wetlands within the property, as well as identifying any important or common wildlife within the site. Citizen science can be accomplished using a phone holder that can be placed at the end of the boardwalk that allows visitors to take a snapshot of the wetland, upload it to a database, which then allows the public to track how the wetland is changing over time. And I'd like to hand it to Taylor to finish us off.
All right, so for a project overview, so far we've talked a lot about our project. We did a site introduction, characteristics, and historic background. We then went on to our goals and objectives. And then we talked about our management plans for the wetland, water quality, wildlife, and public engagement and education. And now I'm going to go into our financial recommendations. First, we have our wetland management financial recommendations. So we have 3 strategies, which are to involve invasive species, native planting, and soil sampling, which cost $975. And below, you can see our trail management strategies. So for scenario 1, that has full, complete restoration, which costs $660. For scenario 2, it's partial restoration, which is $275. And for scenario 3, there is status quo, as in no restoration will be occurring, which will cost nothing. For our water quality management, we have 2 strategies for this. That is the water quality sampling and the reach characteristics, and that'll cost $643. For our wildlife management, as you can see, there's a lot of strategies in this, so I want to name 2 in particular. That would be the duck boxes, which are $450, and the fish and water temperature tracking, which is the hobo loggers, as we've mentioned before. That is $1,178, and overall, these strategies total $2,000. For our public education and engagement, we have 3 strategies, which are the educational signage, the additional garbage cans on the property, and the phone holder, which will cost $1,155. On to our goals and objectives. So after the completion of our management plan, we scored our goals and objectives. And we did it on a grade scale of 0 to 2. 0 meaning it wasn't complete at all. 1 meaning it was completed to the extent of our project. It needs further monitoring. And a grade of 2 meaning it was fulfilled. So for the goal of maintaining ecological integrity, all of our objectives met a grade of 1. For the goal of establishing a long-term wetland monitoring strategy, we have a goal of 2, or a grade of 2 for both of the objectives, so it was fulfilled. And same can be said for the offsetting of water control management costs and impacts. Both objectives scored a 2 as well. And finally, for our improvement of public awareness, both of these objectives scored a 1. We want to give a huge thank you to all the contributors to our project. A big thank you to Frank and Cassandra. We really enjoyed working with you. A big thank you to the City of Fredericton. We really enjoyed working with you as well, and we appreciate your support. And we want to do a very special thank you to Jason. We couldn't have done it without you. And for final remarks, as you can see above, we had a wonderful time completing this project, and overall, we can't wait to see where this project will go in the future. Thank you for listening.
Cassandra, not to call you out, but as our client, if you have any questions for us, or...
I just wanted to say that it was just a field from the city park and parks and trees. Different. I just wanted to say what an excellent collaboration with the 4020 class and that's unlimited installation of that. It's good to see like a piece of land that wasn't utilized to its full potential getting to be something that it should be. Education, animals, the whole 9 yards.
Yeah, and I guess from us alone, we just want to say thank you very much. You gave us a lot of information to think about, digest, and we love that we have monitoring expectations for the site now too that we can implement after we're gone. So yeah, stay in touch. Yes. We're talking about the next box. We've only replaced those as well. So we've identified them, we fixed them, and looking forward to seeing what else we can do. Thank you.
Great, thank you.
Any other questions?
I'm just based on your guys' understanding of the stakeholders being like the local community that's affected. I'm just wondering if with the increased water level in the area, do you know if it will have any impact on the surrounding residential area, or if you spent any time looking at how that will, I guess, traverse past the trail that is almost like the barrier to the residential area?
Ella, would you like to take
Sure.
this?
It's not expected to have any impact on the local or residents around the area because that top trail is like a big berm and it's not, like the water's not expected to increase that much, so it should not go over the top of that trail.
I might add that the locals did seem really excited about the project happening within the wetland. We did have like a couple people that live right along the edge, just very intrigued and interested, giving us recommendations to add like bat roosts and stuff within the wetlands. So they are generally very excited.
I believe, Tom, you had a question?
I have 5 questions. Well, no, I have a lot of questions. First one are all in a group. And how many people are using this land? How many people do you want in there? What do you want those people to be doing? What do you want those people not to be doing? And how much dog food does that include?
So it's a bit of a hard question. So I think Taylor talked a little bit about it. Our property, we weren't able to survey all of it because it was unsafe kind of at the end. There are people experiencing homelessness that do inhabit the wetland currently. which is kind of something that I know the city of Fredericton has been trying to work with, and I know we're trying to kind of figure that out, but right now the goal is to allow no access within the wetland, but because there are the trails on the outside, there is still activities that will occur. I don't know if anybody else got it. Dog poop, didn't see any, but lots of garbage.
Yeah.
Yeah.
I just happened to be walking that trail a couple of weeks ago. I didn't even know that it was your project area. I saw that encampment, and it did seem like not a good place. Is there a canoe kayak launch in there?
Not exactly at our property. There is one, so the nature park that we were watching over and monitoring, that's that area, but then on the other side of the Nashwaaksis stream, there's another area that is used for recreational purposes. I believe that is more easier to dock a kayak. I've seen pictures online of people taking kayak adventures through that stream, but our site, the bankments are probably far too high to bring in that kayak down from our site.
One last question. Do you think that the straw bales would really be enough and effective, like, for preventing the snow melt from eventually contaminating the site? I mean, are there other options? Does the city have other options for snow dumps, or could you do a trench, get that water, the river more quickly on it?
I didn't answer that a bit.
So the
SNODUMP
SNODUMP was established in like the 70s before pre-environmental management regulations and acts. So prior to this, the snow would just be dumped directly into the Ballistic River. So the point of the wetland was to try and help filter out any of the chemicals from the snow dump before it enters the river, which negatively impacts our wetland. So the snow, for example, is dumped right next to the edge of the wetland. So there's the wetland and there's a very small berm to kind of try and prevent snow from entering. But because the snow is dumped right next and right on the edge of the wetland, it goes kind of straight in. So the hope with the straw bales was just to kind of limit the amount of sediment entering, especially right where that Clemson leveler is, as well as just trying to minimize the flow of those chemicals and allow it to potentially seep into the ground of the snow dump rather than into the wetland itself.
Great, thank you.
Joe?
I've got a few questions too. One is you talked about what this will do over the short horizon. We didn't hear what your plans were when this impoundment enters senescence. Most of these impoundments have pretty short shelf lives, so in about 20, 25 years, it'll stop being a productive soil. That's when you will get the typhi infiltration throughout. Have you considered what renovation plans might be necessary in the longer term?
I mean, to be fair, not really. We did look more towards, to be quite honest, we looked more in the short term, just because we were collecting mostly baseline data. However, we do know that the construction of the leveler is gonna have to be monitored, and the point of the leveler is to kind of help the flow and monitor flow. So the hope is that it won't just be stagnant water, the flow can change, so therefore the habitat can also potentially be altered within that.
We also do have, in our recommendations of monitoring the cattail expansion, and if it does get to the point where it's the only thing in there, then we have removal methods and we outline that in our project.
Actually, that's a great segue to my next question.
I can help answer that. I can perspective. Yeah. Project, and yes, of course, you're right that there is a senescence sort of issue, if you will, with these impoundments. So, what we for the leveler, right? There was no picture of the outlet of the leveler, but what we did was put a T on that, and we put a cap on the bottom.
is predicted to decrease in cover because of the shift in habitat. We're losing a lot of that meadow marsh habitat where purple loosestrife would grow. And for glossy buckthorn, that's a pretty complicated removal process. We have, we highlighted a few areas as shown in the map and those have a lot of glossy buckthorn, and that's where more cutting would take place rather than hand pulling. However, because it is a wetland, we do not want to recommend high intensity removal as that would cause more damage to the wetland than benefit.
I'll leave it at that. I won't take any more.
Tommy?
You said that the place floods annually or frequently at least. Any thoughts on Eurasian milfoil? It's a basic plant that really grows legs that kind of environment and even from the small of the fragment can fill water bodies like that. Any thoughts on that? And if it gets there, how would one manage that?
Yeah, so my role was a lot of like native planting. So one thing we really focused on was beating the Eurasian milfoil almost to the punch, if you will. So like ended up planting native plants in like American milfoil to try to already fill that space in the open water wetland. That was one thing I recommended in our study. We have to monitor the movement of that Eurasian milfoil if it gets into our site, and then we'll look, basically the presence and absence of that invasive species will be monitored in the future. But right now, we're just waiting to see the change in our wetland types right now.
And to add on to what Laura said, we mainly focused on invasive species that are currently there that we have identified, and we outlined in the report some threats of other invasive species. However, it would be too extensive of a list to identify the risks of every species that could come into the wetland and affect the wetland functions.
I had one question for you. That site, is it a PSW? And if it is, did you guys run into any roadblocks with doing some of your restoration stuff on your trails? Or?
It is a PSW, but we haven't done any of the restoration, so that's not something that we ran into, but Ducks Unlimited and the city do have WAWA permits to be within the wetland and to do any kind of restoration work. So we didn't do any restoration, we kind of just worked within it, and it didn't impact us. We stayed pretty much within the non-designated trails as well. We tried to minimize our impact on the wetland.
And our group goes into thorough detail about what all of these policies, how that'll impact our client and ourselves while we were doing this baseline monitoring. Yeah, that is further addressed in the report.
This is sort of a general question for the group. If you're conducting a project like this, you have a set of objectives to just show what those are, describe what those are, and then to achieve those objectives, you're going to carry out a set of activities, which you guys have described as well. And normally when doing that, and evaluating what activities you're going to do, you would do some kind of forecasting and some kind of means of understanding, well, will this activity actually lead to my objective? So overall, in your group, what gives you confidence that the actions that you recommend will achieve the objectives that you set out to do? And it's going to vary a lot because you have a lot of different objectives. But what are some of the means that you use to give you confidence that your action will achieve this?
I mean, in communication with Ducks Unlimited, we've been pretty confident that a lot of the information that we're giving them, they're taking. This is baseline data that we've collected. So it's going to be data that's going to be used to kind of just monitor how the wetland changes, right? So we did a lot of communication with ducks, and the whole point is kind of to see how the wetland's going to change. So we do expect some of these goals to potentially, change in terms of that because we aren't sure what's going to happen with that predicted habitat change. I don't know if anybody else has answers.
We did a huge portion, and it's mainly very, very captured in our report, where we forecasted some of the photos that you've seen in this presentation, perhaps the depth to water table. Our GIS incredible member, Ella, really went into these maps and watched how those subhabitats will shift, how that water will impact our site. And we really dove into that, and it's really, really a huge part of what you will see when you read our report, and she got it.
Just as an example, I'm interested in when you recommended planting some of those species to deal with water quality and levels of the water, what gives you confidence that planting those particular species would do? Did you use like those are scientific studies that you were able to do?
Yeah. Are you referring to the phytoremediation?
Yeah.
Yes. So during our studies, we were trying to understand how can this vegetation that's present on the site benefit those chemicals that we found and recognized were causing harm currently. And I dove into the phytoremediation, and I found that it was a really, there's a lot of incredible studies, especially on broadleaf cattail, the common duckweed, and the pondweed, and those were the big hitters. Those were going to have, in the past, there's been studies to do that. And I was also perhaps going to recommend to Ducks Unlimited that perhaps that is a way they could maybe incorporate a student to further that phytoremediation research, so it could kind of be something that they could do on that project and see how those plants further filter. And it's a really cool opportunity. Thank you.
Okay, we're going to get started with the last presentation of the morning. I'd like to welcome up the Lonewater Farm 4020 group with Zach Martins, May McLean, and Alex Cogswell presenting.
Okay. Good morning, distinguished guests, colleagues, and fellow students. I'd first like to acknowledge that the lands where UNB and Lonewater Farm stand are on unceded and unsurrendered territories of the Wolastoqey. My name is Alex, and I'm presenting today with Zach and May, and it is our pleasure to welcome you to our presentation on Lonewater Farm. We would like to thank our client, the Province of New Brunswick Department of Natural Resources and Energy Development. We work closely with Liz and Scott and Holly. I'd also like to thank our partner organizations, Grand Bay Westfield's Recreation Coordinator Rick Adams, and the Nature Conservancy of Canada's Aaron Dowding. And we'd also like to thank the UNB Forestry and Environmental Management 4020 supervisors, Jason Golding and Raphael Lemerink. Today, we will be covering a brief history of Lonewater Farm, project goals and objectives, a property overview and statement of resources, modeling, and our recommendations and operations. We plan to discuss this with the Wolastoqey Nation in New Brunswick. However, we were not permitted to meet with them before the province conducted their Indigenous consultation, which unfortunately did not take place during our project timeline. We do know that in 1859, the young family of David and Mary Essels immigrated from England and established Lonewater Farm. Samuel Essels, their son, carried on the farm with his wife until 1891 after his father's passing. In 1968, Lonewater Farm was purchased by the province as an addictions treatment center and ran for 50 years until the patients were moved to St. John and the facilities at Lonewater were discontinued. It was then made Crown land in 2024 and put under the management of the Department of Natural Resources and Energy Development. For this project, we have 4 main management goals. The first goal, and the most important to our client, is conservation. This includes maintaining the habitat of species at risk and identifying areas to contribute to OECMs. Our second goal is restoration. This includes locating and removing dump sites and identifying invasive species. Recreation is an important goal for this project. Our objective here is to improve the existing trails and increase the educational engagement opportunities on the property. Additionally, we aim to maintain the boat landing and reduce the usage of motorized vessels. Our third is engagement. We plan to partner with conservation groups and incorporate rights holders and stakeholders' values into our management plan. I'll now go over a statement of resources of Lonewater Farm. Lonewater Farm is a 167-hectare piece of crown land located in Grand Bay, Westfield. The property is 85% forested, 8% non-forested, and 7% wetland. Our forest inventory showed that Lonewater Farm has a total of 138.8 hectares of forested land. It has a density of 1,500 stems per hectare. Stand compositions are made up of softwood, which is 59%, mixed wood is 31%, and hardwood is 10%. In the forested areas, the most common species is balsam fir, which dominates at almost 50%, followed by red spruce at 15% and white birch making up 9%. A few species of interest here are black ash, silver maple, and a variety of apple trees still on the property. Our wildlife data is limited to bird species. This information was collected from autonomous recording units placed on the property in late spring and collected information throughout the summer. We first ran ARU data through Raven Pro software to identify the calls. We then had Dr. Nocera's PhD candidate and ornithology specialist, Kirsty Owens, audit our data, and she was able to ID 18 at-risk bird species as seen here in the table. This information was important for our wildlife suitability modeling and our recommendation section. A large portion of Lonewater Farm is located along the Narrapis River, which results in a significant amount of wetland. During field collections, we conducted a wetland delineation and have a new proposed boundary, which increases the wetland by 5.6 hectares. This is a 106% increase from the original wetland area. The map here shows the original wetland area in light blue and the new wetland area we are proposing in dark blue. We interviewed different conservation groups that work in and around the Grand Bay Westfield area. During interviews, we asked about possible resource sharing opportunities that may align with the client's goal for the property. We were able to incorporate the conservation group mandates into our recommendation section. Our stakeholder interviews were also essential in collecting information on the organization's values and mandates, as many of these groups have land trusts near or bordering Lonewater Farm.
Next, I'll move into our modeling section. Forecasting how a forest changes over time provides insight into its future conditions. This includes species composition, forest growth, and habitat availability. We want to account for these changes as they may affect a project's objectives. PICUS is a model that simulates how trees interact on patches of 10 by 10 meters. It predicts composition change of stem density, basal area, and volume, all while accounting for climate change. We chose this software because there is no harvesting in our management plan, but what really matters is understanding change under different climates. Our client has a 25-year planning horizon, so we decided to forecast for this timeframe, as anything further than that would become more uncertain. Examples of uncertainty are pest outbreaks, weather events, and anything that would cause major disturbance. And the main uncertainty we wanted to account for was climate change. For this project, Lonewater Farm was forecasted in the future under its current conditions with no management and no major disturbances. This shows the growth, mortality, and species changes that would naturally occur. Forecasting a status quo scenario provides a baseline to which results from other scenarios can be compared. Our status quo scenario is climate normal, which is an average of the climate patterns from 1980 to 2010. This is a hypothetical future where we are not very concerned about climate change. Then, we forecasted two climate change sensitivity analyses, RCP 4.5 and RCP 8.5. These RCP scenarios simulate climates that are based on greenhouse gas emission levels. 4.5 shows a scenario in which emissions increase until mid-century and then plateau. And 8.5 shows a scenario in which emissions continue to increase to the 21st century, and it is the worst-case climate change scenario. These analyses allow us to assess a realistic species composition change and assess wildlife habitat availability. Here is a graph showing the stem density change over time for all climate scenarios in our intolerant hardwood stand type. We chose to talk about the stand because when we were modeling for wildlife habitat, this is where most of it was found. Overall, the density decreases over the next 15 years and then begins to increase again. This is a result of forest succession as trees compete for resources. When trees die, resources such as space and sunlight become readily available and stimulates the growth of regeneration and saplings. At the end of our projection, climate normal reaches relatively the same density as it started with in 2025.
There's a specific amount of growing degree days that is optimal for species growth. You can kind of think of it as a peak amount of growing degree days. Different temperatures or climates have different amounts of growing degree days. Here in southern New Brunswick, many species are slightly below that peak of growing degree days. So under a warming climate, there would be more warm days, so more growing days. As seen in the 4.5 scenario, there's a slight increase in temperature, so it would move those species closer to that ideal range of growing degree days. The 8.5 scenario shows a similar trend to the climate normal scenario, as it is on the opposite side of the peak as the climate normal. The climate normal is slightly below the ideal range, and 8.5 is slightly above. This is a breakdown of the 3 species that are currently the most abundant in this stand. Balsam fir makes up almost 40%, and red maple and red oak make up just below 20% each. Balsam fir density decreases across the first 15 years, which is expected, as it is the most abundant in the stand, and this is the trend we saw with the overall density. For climate normal and 4.5, it increases slightly as forest succession occurs. The 8.5 scenario, on the other hand, shows a continued decline in balsam fir. This is because it does well in cool temperatures and abundant moisture, which are characteristic of southeastern Canada. Under a warmer climate, these weather patterns change, impacting the growth of balsam fir in this region. Red maple also shows the general trend of decline and then increase, but when compared to balsam fir, the increase in red maple is quite noticeable and occurs over a shorter period of time. Red maple does well under a wide variety of climate conditions, and that is why we see its increase here. Under the RCP 4.5 scenario, red maple is closer to its ideal climatic conditions relating to optimal growing degree days, and that is why it is higher than the other 2 scenarios. Red oak shows a continued decline over time across all 3 scenarios. In the RCP 4.5 and RCP 8.5, it begins to increase again because of the temperature increase creating more growing degree days, pushing it closer to its ideal range of growing days. And the climate normal continues to decline until the end of the forecast because it is not increasing in temperature and it will continue as it is. Red oak is a slow-growing species and it produces slower than red maple, which is why we see a more gradual and slower increase than the other species.
Right. One of our goals for this project is to protect species at risk habitat from further anthropogenic disturbance. From the 5 ARUs placed around the Lonewater farm, we identified several at-risk bird species that are actively using the land. Since the primary function of our property is for conservation, most of the future anthropogenic disturbance is going to be limited to the construction of trails through the forest. So, of the species identified, we selected those that require the types of forest that are present as breeding habitat, which ended up being the eastern wood pewee, Canada warbler, wood thrush, and evening grosbeak. We also modeled for white-tailed deer overwintering habitat, since we know that they are present on the property and are a socially valued species. We used species-specific habitat variables such as stand composition, stem density, distance from edges, just to name a few, to create habitat suitability values at a 10 meter by 10 meter resolution using LiDAR and our forest inventory data. Each variable is scaled and weighted based on its significance to the species. The dark green cells indicate areas of high suitability, and red areas indicate low suitability. Now I'll be going through some of our recommendations for the property, which goals each one fulfills, and which partners may be able to help with their implementation. To meet our conservation and recreation goals simultaneously, we are recommending that future trails be placed in areas that minimize conflict with the species previously mentioned. To do this, we merged all areas with 80 to 100% suitability for each species into one map, represented by the green areas on the map. There were 5 kilometers of existing trails already on the property, indicated by the solid red lines, and we are proposing the addition of 1.9 kilometers of additional trails, the dashed lines. The proposed trails would connect existing trails into several loops, while avoiding important breeding and overwintering habitat as much as possible. The trails are also placed to avoid stream crossings where possible to minimize stream degradation, and as a precautionary approach to reduce the disturbance of other potentially at-risk riparian wildlife. The Nature Conservancy of Canada stated they may be willing to partner with the client to help implement these changes. In the southern portion of our property, there's a field with few trees where milkweed is currently growing wild. Milkweed is a critical requirement for monarch butterflies, an at-risk species that has been confirmed as present on the property, and is susceptible to exclusion over time due to natural forest succession. To mitigate this issue and ensure that monarchs can continue to use the property into the future, we propose building a series of garden boxes and planting milkweed as well as other native wildflowers. Educational plaques can accompany the garden boxes to educate Lonewater Farm users on the planted species and their significance. ACAP St. John would potentially be able to partner for this one. Because this project only began in late summer, we were not able to survey for flora and fauna that are most visible or active in the spring, such as herbaceous plants, amphibians, reptiles, and arthropods. Because of this, we were not able to conduct any meaningful surveys for these taxa and would, therefore, recommend that surveys for their presence be performed in the spring. The Nature Conservancy of Canada may be able to assist by providing resources for habitat and species identification and monitoring. Since this property used to be a farm and continues to be used by the public to this day, there are a number of dump sites scattered around the property, as well as several smaller scattered areas of garbage. We recommend that these be removed in an effort to reduce the human impact on the land and prevent the potential for injury, as some of these dump sites contain large, sharp pieces of metal as they were some farm equipment. Here we have a map of some of the dump sites that were located during our forest inventory. However, there are likely more sites that we didn't find that need to be cleaned up. And for this reason, we recommend a more comprehensive survey to locate and remove garbage. ACAP St. John stated they may be willing to assist with this. We located and identified a handful of invasive and undesirable plant species spread across the property, some of which have the capacity to outcompete and replace native species. We recommend that where possible and feasible, invasives be removed. I say where possible and feasible because in practice, the removal of some species like glossy buckthorn is neither. But where there are only small patches of them, like the Himalayan balsam, they are much easier to remove. Our invasive species survey, like our dump site survey, was incidental, which is why we also recommend performing a more thorough survey of the property to locate invasives. The Nature Conservancy of Canada and the Nature Trust both stated they may be willing to assist with invasive species strategizing and removal. Our clients wish for the property to be used for conservation and recreation, but also for education. To meet this goal, we propose the construction of a sheltered learning space, like the gazebo pictured here, to house benches and a variety of plaques and signs to educate visitors on the history and ecology of the property. It would ideally be located on the site where the previous rehab building was located to reduce the environmental impact. The milkweed flower beds could be located alongside or surrounding the gazebo, as well as their accompanying plaques to further improve the educational experience. Once trails are constructed, we also recommend that maps be placed at junctions to help users navigate, and plaques placed at specific locations along the trails to educate them on landscape features, species, and historic sites. ACAP St. John and Ducks Unlimited are two possible partners for this endeavor. There's currently a boat launch in use on the property that allows people to launch motorized vessels into the Narrapis River. Given our clients' conservational priorities, they would prefer that the boat launch be used only for non-motorized vessels like canoes and kayaks. To meet this goal, we recommend one of two options. The trailer launch could be blocked off entirely, allowing only hand-launched boats to be placed in the water, accompanied by signs detailing the changes. It's worth noting that there is another boat launch nearby on the Narrapis, so removing this one would simply force boaters to use the other. However, this does create the potential for conflict with local users, so our alternative recommendation would simply be to leave the boat launch as is and erect signs at the boat launch discouraging motorboat usage. When working with Crown lands and proposing alterations, there is a duty to consult with Indigenous groups. With that in mind, we recommend that consultation with rights holders be done early and often throughout the project management process. Ideally, this consultation results in meaningful, long-lasting, and collaborative partnerships with the WNNB. for stakeholders. There was an initial survey done this summer by the town of Grand Bay Westfield to determine stakeholder attitudes, opinions, and property usage. However, this survey was only available to the active users of the property. We recommend that another survey be created and distributed to a wider demographic across Grand Bay Westfield to understand local interests, create excitement about the project, and increase usership. We also recommend that consultation with local schools and educators, recommend consultation with local schools and educators as they may have valuable insight into the most effective education strategies that align with their curricula. An OECM, or other effective area-based conservation measure, is a geographically defined area that is not technically a protected area, but achieves long-term conservation and biodiversity while still allowing for certain types of recreation. OECMs are a key land designation tool used to help Canada reach the goal of preserving 30% of land and inland waters by 2030, and designating the Lonewater Farm property as one would help both Canada and the province meet their conservation goals. All 167 hectares of the Lonewater Farm property currently meet the requirements of an OECM and would remain an OECM even with all of our recommendations implemented. And that concludes our presentation today. Thanks everyone for listening. We appreciate your attention. Now I'd like to invite the rest of my group up to answer any questions that you may have.
How would you put some detail around that statement that it's
Proven
proven?
biodiversity outcomes. Well, there is the management plan for the land is currently our management is pretty minimal. You know, the only construction we have is pretty limited trails, and so I guess we aren't any kind of harm to the biodiversity on the property would be very minimal. And so
it gets into issues of viability.
Individual population viability?
Populations persisting. Again, like earlier, not so much as the presence of one pair, but as there are 20 pairs, population as opposed to something much less. There's enough area for this to be functional. That sort of question.
I guess it is kind of a bit of a gray area, but it is connected to other large contiguous patches of forest that is, I guess, disturbed minimally. But I guess it is a bit of a gray area.
In terms of persistence, I'm curious why you chose evening grosbeak as one of your focal species, because it's notoriously unpersistent. It's nomadic, so you can predict all the habitat suitability you want, but they move around all of Atlantic Canada in a given year.
They were detected. They were one of the species that were detected that are listed under SARA, or the Species at Risk Act.
Not yet. They're recommended by COSIWA.
I guess we used both COSIWA and the Species at Risk Act to determine which species we're going to be speaking about. But
consider that for your report, because they're notorious for being in one spot one year, and then you won't see them for 6 or 7, and you'll see them again. So put in parentheses fickle or something.
Okay.
I love your timeline and the fact that you dug into a little bit of the history. But what happened between 1891 and 1968? There's kind of a gap in your information.
There is a gap because I could not find any information on it. I went through the provincial archives, and I also looked through historic aerial photos to look for any hints or clues as to what it might have been used as. But I could not find anything to fill that gap. I'm not sure if maybe it was after Samuel, the son of the people who first came and created Lonewater Farm, if after he passed away, I don't think they had any children, so I'm not sure if maybe the land was just unused for a couple years and the province saw an opportunity to purchase it because it wasn't being used or technically really owned by anybody. But I don't have any solid information as to what was happening during that time.
Would tax records be, or
Maybe.
like, what did you see in the area of property? Like, did it used to have more farmland that reverted to forest, or?
Yes, we did see the forest encroaching a bit after the farm was no longer being used as a farm. It did have a lot of apple orchard on it, which is still present, some of the apple trees. However, it went from being farm, and then the next kind of like aerial photo that we had showed the infrastructure for the addictions facility.
I'm curious about, like, there's a lot of balsam fir there. Balsam fir in any climate change scenario is not projected to do well. Is that a concern? Are you going to do anything about it? I recommend that anything be done about it, or just let nature take its course?
Well, it's not really a concern. Forest succession happens naturally, whether climate change is present or not. If we were to make any recommendations, it would be to like plant climate resilient species, but this is something we've talked about with our client. It is kind of an option, but not necessarily one that is seriously being considered, because this is kind of for conservation methods, so just letting nature take its course.
Okay. It's interesting, I mean, because balsam fir still recruits the next generation extremely successfully, right? So if it doesn't have a long-term future, I've always been curious about what that means. Like, is it going to live to be 30 years and die off, and then still another generation of young balsam fir that's not going to reach maturity occur, or what? Did you explore that at all?
The way I understand it is that balsam fir density isn't as impacted as the balsam fir growth, like annual growth. So balsam fir will just grow at a slower rate. And then that also goes with seed production likely. Anthony.
So I realized that you didn't have the opportunity to sample for reptile, but one of the reptiles that's decently secure in the Nashwaaksis is wood turtle, and there's lots of records. Did you have access to historical records about occurrences on your property?
We did have access to records, but not on the property. I don't think we did some.
Of wood turtles?
Well, I'm using wood turtles as an example because I know that they're well documented across the Nashwaaksis, particularly by ForEM and National Defense. So I was wondering if there were wood turtle records for your property or records of other SAR.
Well, we did have access to ACC DC layer. There has been a record of a painted turtle on the property, but there's not been a record of wood turtles.
But also a lot of the kind of a lot of the areas that were green on the map, they also just happened to be a lot of the wetland down by the water. And so, as I mentioned, like we're staying away from streams, but we're also just staying away from the water, kind of as that precautionary approach, because we know wood turtles and salamanders are likely present, but we just don't have any proof at the moment.
Well, just two questions. Just going to start more philosophical. Taking us back and forth to 2006. So if it's doing nothing activity-wise, would that be still considered management?
Yes.
Of course.
Yeah. I knew you were going to say that.
Good job, Meg, explaining that same dynamic, because it's complicated. But just as a quick extension to that, like, so you guys did some stand simulation work and the climate change, and you saw some changes in composition. Does any of that translate over to significant changes in habitat? Because I know part of the project was these habitat objectives as well. Did that climate change, kind of RCP 8.5, does that translate over into changes in some of the habitat you need to be concerned about?
We didn't actually model habitat change into the future. What we would have been able to model would have been limited because a lot of the habitat modeling relied on LiDAR data, and obviously we can't access future LiDAR points. So I did actually run through one really quickly, but the change was essentially negligible in our modeling. Not to say there will not be any change, but we weren't able to accurately model the change.
Or just anecdotally, based on your own experience, given those changes that you saw in composition, is there anything that stands out that, you know what, with this change in climate, it's going to be bad for this species or that species, wildlife-wise? Or,
Perhaps for like grosbeak, but again, I guess they're not. They eat a lot of seeds and budworm, but we kind of manage pretty heavily for budworm. And if balsam fir is leaving, then perhaps they would be affected more so. But I can't. Yeah, again, that's kind of anecdotal.
I just had a question out of curiosity. Your property boundary has this funny curly shaped bottom, and I kind of noticed that maybe it doesn't go around quite everything that's on the wetlands. I'm just wondering what that, if you know much about that boundary, why it's drawn like that.
I'm not entirely sure what you mean. What? I guess we can skip back to it somewhere.
It was just out of curiosity.
At the bottom?
Yeah,
Where it picks
like,
up?
and then it doesn't quite cover, like it looks like there's some kind of points that stick out. I was just curious.
That area is heavily flooded,
Okay.
so the boundaries get pretty ambiguous. Like when we were there, that's all water, and even in the dry area, based on aerial photographs, at best it's wet vegetation. So I'm guessing it was difficult to survey and lay down a strict line.
It's all grass.
I have a question about the dump sites, actually. Like, are these kind of like actively used by people now, or are they historic, or?
Some of them, yeah. I mean, it used to be a farm, and so there is some old farming stuff, old farming equipment. That's what I was talking about, like sharp metal. Some of it is kind of dangerous. And then there are people, I mean, people do love the property, and they still come and use it. Some people have like hunting setups, and so there is some trash, old cans and stuff. And then there's a hot tub. We found a hot tub, which was an interesting one. Don't know if they're actively using the hot tub, but.
It's not like active dump sites where people are told to go, or a lot of people are consistently dumping in one area. It is just the most random stuff that's just thrown there out of sight, out of mind.
Yeah, like old farm dumps are super cool.
Yeah, they're.
People dumping their trash because they don't want to go to the landfill. It's not cool.
Yeah. Cool and not cool. Yeah.
Question for that.
Yeah, I was curious what went into the delineation of the habitat for your maps for this last week. You mentioned the fact that you consider delineating that within the habitat.
For like, you want each individual species habitat variables?
Like in general.
Okay, well, they were each different. They're species specific. And so, species like forest composition, distance to riparian areas, overstory, cover, I guess, understory cover, what else? Slope, distance to roads, distance to edge.
A big one, yeah, distance to hard edges was one thing, distance to road edges. Some species, distance to a hard edge, for example, a field was favorable, but if it was a road, no longer favorable. So yeah, it's a lot of rasters.
Was there any questions from our clients?
Not a question. I think that you guys have done a really great job, and I look forward to seeing the final report kind of getting into especially the model a little bit more and the influences are and colors, how we're going to move forward with our management plan for this stuff.
From a town perspective, we're obviously hoping to see recommendations that supported recreation within that conservation model. So where you're at right now is lovely for the town, and obviously we need to work with partners to actually make it come true.
Good afternoon, everyone. How's everyone doing? Ready for the afternoon presentations? Ooh, 3 more left. Okay, I want to introduce the New Brunswick Aboriginal Peoples Council with Alicia Lau, Madeline Yerksa, and Liz Phillips presenting.
Alrighty, I want to just take a moment to thank everybody for joining us after lunch. We're here to represent the Little Lake project in collaboration with the New Brunswick Aboriginal Peoples Council and with UNB's Forestry and Environmental Management faculty. My name is Alicia. I'm here joined by Liz and Maddie, and we're just going to get right into it. So starting with a little outline of what we'll be going over today, starting with our introduction, our goals and objectives, followed by our inventory results, the state of those resources, and then finally our recommendations. So here we will dive into the outline of our project, which will include a little bit about our client, the significance of the Little Lake property, and then some overall project details. NBAPC is the voice for approximately 28,000 status and non-status Indigenous people who reside within the province of New Brunswick. Their mission is to provide off-reserve Indigenous people with opportunities to advance their culture, economic well-being, and overall living conditions. They work to reaffirm treaty and land claim rights while strengthening cultural identity in New Brunswick, both independently and in collaboration with other Indigenous organizations. Their focus includes self-governance, ensuring jurisdiction over renewable and non-renewable resources, education, health, and social services. All of which were aspects that the Little Lake property strengthened. NBAPC was founded in 1972 with the goal of creating a space for youth to engage with the land and learn their cultural practices. In 1982, the council obtained confirmation from the Department of Natural Resources that the application for lease of land on Little Lake had been approved. By 1985, the site housed a main hall, 5 cabins, and essential infrastructure enabling them to hold the 14th annual general meeting and the 9th annual summer camp. Although in 2008, over $20,000 worth of damage was inflicted on the property by vandals, and in 2021, a fire destroyed the main hall. Previous restoration efforts had been made, including the creation of the Little Lake Cultural Foundation in 2015, and temporary repairs to the Rising Sun Lodge allowed them to hold the 46th annual general meeting in 2017. Unfortunately, a summer camp hasn't been hosted since the late 1990s, and the camp has fallen into further decline in the years leading up to the present. Today, only 5 small cabins, 1 larger building remain, all in unusable condition, with debris from fire damage, illegal dumping, and further vandalism spread across the property. What once was a beautiful addition to the NBAPC is now a dangerous and desolate property, in which the main goal is to restore the Little Lake property to the previous conditions and to ensure cultural sharing is maintained for many generations to come. So some overall project details about the site. It is located just outside Tracy, New Brunswick, off of the Pelotoма Settlement Road, and the property is approximately 5 hectares in size, resting 50 meters away from the shore of the lake. The site is composed of 3 distinct stands, 2 of forest nature, and 1 comprising of the building area and field. Here you can see the larger forest stand represented in green, with the slightly turquoise off to the right being the smaller second forestry stand, as well as the building area and field highlighted in pink, with the green blobs on the map representing the standing infrastructure, and the red representing the fire sites, with the larger being the burnt main hall. The Little Lake project aims to develop a plan for rehabilitating the former summer camp and Rising Sun Lodge. This initiative seeks to integrate environmental restoration with community involvement, ensuring the site's renewal for future use. A key focus of the project is restoring the natural environment for NBAPC members, enabling the property to serve as a space for cultural teachings and community engagement. Additionally, the project aims to assess the future of the forest, document the presence of medicinal plants, and promote sustainable land use through a comprehensive management plan. And now I will pass it off to Maddie.
All right, so with the help of NBAPC, our team established 3 areas of goals and objectives for this project to best meet the client's expectations. And these 3 categories were environmental, social, and economic goals. So our social objectives were to consider the perspectives of NBAPC members. Our environmental objectives were to define the flora and fauna on the site and to identify any medicinal plant species on the property. Our social objectives were to gain insight from NBAPC members and consider them in our management plan, to increase educational opportunities and historical knowledge on the site, and to identify cleanup and rehabilitation measures on the site. Our economic goals were to create economic opportunities for Indigenous communities and to identify quotes and funding opportunities for the cleanup and rehabilitation of the site. So after 2 months in the field in the fall and a month-long survey that circulated through the NBAPC members this past February, all of our final results are here and summarized to be shared with you. As NBAPC is strongly influenced by its membership, our social results were at the center of our project and helped us guide in our management recommendations. And in response to what the membership would like to see this property used for, the top 3 answers were knowledge sharing, community and land sharing, and land access and medicine. In response to what the membership would feel that would help them best connect to this property, the top 3 answers were to once again host AGMs on the property, to host cultural teachings on the property, and to restart the youth camp that was once held there. The biggest issues that membership have with the Little Lake property are the lack of knowledge of the site in general, vandalism of the site as it has been a problem in the past, the distance and travel costs associated with getting to the site, and in general, a lack of services on site, so lack of Wi-Fi, basic amenities, and distance to hospitals in cases of emergency. And now we'll move on to our forest results. These are going to be divided into our 2 stands. Stand 1 is balsam fir dominated with presence of eastern white cedar and black spruce. And similarly, stand 2 is balsam fir dominated, also with white cedar and black spruce. So in terms of species composition, they are very similar, but in a bit when I hand it over to Liz, she's going to talk about the differences in age and forecasting between the stands. Our vegetation results are also divided by stand and also include the field portion of the property. In stand 1, the 3 most abundant vegetation species were bunchberry, bracken fern, and steppe moss. In stand 2, the 3 most abundant species were Bassania moss, dicranum moss, and Schreber's moss. And in the field portion, the most dominant species was grass species, followed by highbush, blackberry, and bedstraw. Moving on to our wildlife results, we used camera traps to take inventory of the more timid species that we were less likely to encounter in person on the site. And the 3 species that encountered or were found using the property the most were white-tailed deer by far at 61%, followed by eastern coyote, and then 3rd place was tied between moose and, interestingly, a Canada lynx that was found frequenting the site a couple of times. We also used transects to find any signs of wildlife using the property, but for sake of time and interest, we're just going to talk about the wildlife we actually encountered on these transects. And the top 3 were Canada jays, golden-crowned kinglets, and a tied for 3rd was red squirrel and chipmunk. So as NBAPC was interested in reestablishing a medicine trail on the property, we asked the members in our social survey what culturally significant species they would like to see on the site, and this was the list that they provided us with. Unfortunately, a number of the species are not found on the site, but luckily cedar, winterberry, birch, and maple species are found on the site, so this was taken into consideration when designing the medicine trails. In terms of culturally significant wildlife species, this was the list that NBAPC provided us with. We found no indication of bald eagle using Little Lake, but that's obviously limited by our survey efforts and the time of year we were surveying. But deer, moose, hare, and grouse were all using the property in some capacity. And I'm going to pass it over to Liz.
Now I'm going to walk us through the state of our resources on our property, followed by the model scenarios that we ran and a sensitivity analysis that we conducted on our model scenarios. So just as a quick stand overview, stand 1 is 3.7 hectares in size with an average volume of 137 cubic meters per hectare. The average height was 9.3 meters and average diameter at breast height was 12.7 centimeters. We estimate the age of the stand to be around 58 and its corresponding density is around 1,500 stems per hectare. Stand 2 is quite small in comparison. It's 0.4 hectares in size with an average volume of 181, height of 7.5 meters, DBH of 9.3, and we estimate the age to be around 39. Its corresponding density is around 2,500 stems per hectare. This suggests that there are 2 cohorts of trees in each stand in the stand initiation and stem exclusion stages. We predict that this is possibly due to the extreme wind event which occurred in 2021. We used our forest inventory to conduct an estimate of the current product volumes on our site in conjunction with a product ratio calculator. In stand 1, in terms of hardwood, we have about 77 cubic meters of saw logs and 1,800 cubic meters of pulpwood. In terms of softwood, we have around 1,200 cubic meters of saw logs, 17 of pulpwood, and 18 of studwood. In terms of modeling, we wanted to ensure that we were in alignment with the NBAPC's objective of using inventory data, technology, and consultations to forecast change in forest composition and structure over time. We chose a period of 50 years. We also wanted to model to understand how forest conditions are expected to change over time based on climate and prescription. To model, we used PICUS, which is a hybrid ecosystem software combining the stand physiological data that we collected in the field and scenarios to create a 3D patch model in response to our changes. The first scenario that we have is today's climate with a conservation objective. In terms of conservation, we are talking about no intervention or prescription to occur on the property. Today's climate is referring to data that Base Gagetown here in New Brunswick has been collecting since 1981, and we use those in conjunction to model. At the bottom of the slide here, you can see the top 4 species that we are looking for when we model, with balsam fir in blue, black spruce in orange, eastern white cedar in gray, and red maple in yellow. So in stand 1, you can see that it has a consistent volume until around the year 2034. This is when mortality begins to increase, and in 2056, regeneration begins for all species. In stand 2, the volume also steadily decreases in the current climate and increases again in the year 2066. We predict that this is because the stand is reinitiating. Our next scenario was a worst-case scenario with the same conservation objective. Worst case here is referring to the Government of Canada's representative concentration pathways. The RCP is projections of temperature due to greenhouse gas emissions and the resulting impact they have on climate. This is used by the Intergovernmental Panel on Climate Change to model in their assessment reports and therefore is a trusted resource. We used their 8.5 degree worst case climate scenario. In stand 1, you can see that this climate change scenario resulted in cold adapted species such as balsam fir and black spruce to be become suppressed and decline due to higher temperatures. Overall, stand volume decreased, likely due to drought, which resulted in this long decline compared to previous scenarios. Red maple in yellow regained its volume due to its projected ability to fare well in the coming changing climate. In stand 2, the volume is also expected to decrease, but it's not expected to recover. Our final scenario was a worst case, the same 8.5 degree increase in temperature, but with a management objective. This was a 10% balsam fir select low impact harvest, followed by a 200 stems per hectare fill plant of red oak. In this scenario, the harvesting was not significant enough to show on the graph, but all species can be seen to decline due to the larger increase in warming. PICUS predicted that red oak would have a very small increase in volume over this 50-year period following our planting operation, and red maple increased in volume and abundance once again due to its climate adapted characteristics. So we ran a sensitivity analysis on our RCP pathway projections and historical data for our model scenarios. We noted all external factors that we deemed would impact the project, resulting with a rating on how the factor will impact from low to high and the probability of its occurrence on a scale of low to high as well. This is a table which summarizes all of our findings. We deem that most likely to occur is vandalism and wind events with high severity ratings. The property has a history of vandalism which continues to alter it to this day, matched with there's currently an abundance of blowdown, which is creating an edge effect. In addition to the advanced age of stand 1, the trees on the edge are more prone to wind throw, matched with a decrease in live crown ratio. Overall, this contributes to a lowered resilience and stability of the stand. And now I'll pass it off for our recommendations.
So based off of our inventory results and modeling scenarios, we have compiled a series of recommendations that would best align with our set goals and objectives, and these will be broken down into their respective sections. So starting with our social recommendations, we have provided 3 management scenarios for the NBAPC property, each with varying levels of intervention and investment. These options range from minimal intervention to a more proactive approach, balancing financial constraints with community engagement. It is important to note that there is no status quo option, as intervention management on the property is of high priority to NBAPC, and thus all scenarios build on top of each other. So starting with management scenario 1, minimal intervention, this includes the decommissioning of the structurally unstable buildings, confirming the legal boundary, and removing the debris and waste on site. With this approach, members of NBAPC can use the property for low-impact events, but restoration efforts, including the construction of the main hall in the summer camp, would not be addressed. One other major challenge is the site's vulnerability to unauthorized access and trespassing due to a lack of structured oversight, which would also not be addressed in this recommendation. Costs associated for this scenario would include the demolition and debris removal, which we have outsourced to a local construction company in Tracy, who provided a quote of approximately $21,000. The boundary confirmation is essential for this scenario, as well as during our inventory results, we experienced a slight skew in the UNB's boundary approximation, and thus we recommend that a boundary confirmation is included within this recommendation, and the costs associated with that would be approximately $1,500, $400 for the application fee, and $1,100 in associated legal fees. Pros for this option would be that it allows NBAPC a longer timeline in future forward planning for the essential infrastructure in order to host the summer camp and AGMs, although cons associated with this option would be the limited use of NBAPC members for structured activities, as well as potential continued degradation of the property and the costs associated with this scenario. Moving on to our second option, which is the inactive precautions. This option focuses on improving security measures to protect the property and deter the unauthorized use. This we would recommend using signage indicating the property boundary and ownership, as well as implementing further surveillance cameras in these key areas, as well as a routine maintenance by a designated staff member on a monthly basis or however frequent the NBAPC deems fit in order to upkeep that active involvement on the property. While this option increases security, it does not fully engage the community in restoration efforts. Costs associated with this option would be the extra no trespassing signs, quoted to be approximately $90, and the increased surveillance cameras, which have varying costs depending on model and number, but there's more information within a report on the specifications. Pros for this option would be that it reduces the chance of vandalism overall on the property, but cons that it is a moderate investment, as well as it does not, again, fully engage community members in the restoration of the Little Lake property. And finally, our third scenario would be the proactive approach, which is the most comprehensive approach that emphasizes community engagement in the restoration of the property, which would include the construction of the main camp and lodges, as well as establishing spaces for sweat lodges, cultural gatherings, and further workshop hosted by NBAPC, as well as partnering with the local community to foster an understanding and respect for the site, educating the local Tracy village on the site significance and importance to the NBAPC could decrease vandalism and unauthorized use into the future. This approach integrates the security measures from the second scenario while also promoting a long-term sustainability of the property. The cost for this is highly dependent on the design of the proposed structures, but can be reduced through volunteer work, as in our social survey we did ask a question if members would be willing to volunteer their time and their crafts. So pros for this approach would be that it strengthens community ties and cultural revitalization to the property, as well as ensuring long-term sustainability to the Little Lake property. But cons would be that it is a higher financial and resource demand for the NBAPC, and that there is potential initial resistance from non-NBAPC members. Each of these options presents different benefits and challenges. The minimal intervention approach is cost-effective but limits community engagement. Inactive precautions improve security but do not fully address restoration. And the proactive approach provides long-term sustainability but requires a higher investment overall. Moving forward, a balanced strategy that considers both financial feasibility and community involvement will be crucial, which is where we recommend the immediate implementation of option 2, the inactive precautions, and then a phase into the proactive approach over the next 2 to 5 years in order to reestablish the hosting of the summer camp and future AGMs at the property.
In terms of forestry, we have 3 possible options for the NBAPC to follow. The first is a status quo operation where no intervention or prescription is to occur on the land. This is the most cost-effective option while also allowing the forest to develop naturally, but it means that construction material will have to be outsourced in order to rebuild the property. Our second option is a planting operation of 200 stems per hectare of red oak. This is an established member of the Wabanaki and Acadian forest. It's long-lived and climate resilient. The plant is to occur in areas where the canopy has opened due to disturbances. This will boost diversity of the stand, and it's beneficial for wildlife who use the area. As a result of our social survey, we have an extensive list of volunteers willing to aid in this project however they can. Once the site is deemed safe for the general public, we propose a volunteer planting operation can occur where members can visit the site, see the progress, and plant some trees. The con to this operation is the cost and availability of seedlings. Right now, we project the cost to be around $1,100. Our final forestry recommendation is a low-impact harvest and fill plant operation. We would like to see 10% removal of balsam fir through a low-impact select harvest where felling is carried out via a chainsaw. Then we would like to see planting of approximately 738 red oak seedlings in the same method as our previous option. A member of the NBAPC is currently certified and already has the required equipment and experience to carry this recommendation out. The removed volume could be used for building materials for the summer camp as it once was in the past, with a minimal impact on the forest's overall density. We suggest the purchase of a portable sawmill, specifically the Woodlands Mill HM126 ground-mounted portable mill. The cost before taxes is around $3,500, but with the product dimensions and adjustability of this machinery, it is a worthwhile investment. For products to be used in construction operations, they must be graded. This means that the products must be categorized based on quality, appearance, strength, and therefore overall suitability for construction applications. So we recommend additionally that a member of the NBAPC complete the 2-week grading course put on by the Maritime Lumber Bureau to ensure materials are fit for use. This is an added cost, but the course is valid for 3 years and allows independence and flexibility within the NBAPC to create these products while also opening a possible employment opportunity. So in terms of pros, we can use the harvested trees for construction material while increasing tree diversity with a highly adaptive species. Cons are the upfront expense of the portable sawmill, access and transport of this mill, along with the same seedling availability and associated costs of $1,100. But this final recommendation is the highest recommended option that we urge the NBAPC to follow.
Our first recommendation for wildlife is status quo. This would be no additional cost to NBAPC, and although the property is small, it is still all right to support smaller wildlife, for example, ruffed grouse that the membership showed interest in. An obvious con is that it does not meet the range requirements for many wildlife species. So what this would mean is that you're significantly lowering the chances of the membership being able to connect with the wildlife species that they have showed interest in. So for our second option, this would be land acquisition with a minimum recommendation of an additional 5 hectares. This would help meet the range requirement of the wildlife species that the membership is interested in. For example, doubling the property from 5 to 10 hectares on top of the already established conifer dominant forest would make it adequate deer wintering habitat, and white-tailed deer is a species that the membership is interested in. The con is that it would be an additional medium to high cost. And although the site can't support many wildlife species, it is clear that the priority right now is to focus on rehabilitating the site for use for the membership, which is why we would suggest remaining status quo with the suggestion of reconsidering acquiring more land in the future as we move into a more proactive approach. We provided 2 options for a medicine trail on the property. The first one is around 400 meters long, and there are the medicinal plants highlighted along it that the membership is interested in. This would be no additional cost, and we would provide a map such as this, as well as a list of the species and their significance. The obvious con is that there would be no signage in this option, so it would be a bit more difficult for interpretation, which is why we also have option 2, which is a longer 600-meter trail. Medicinal plants are also along the way, but we would suggest adding benches and signage along the way. The cons is that this is a medium cost for benches and signage. Although it is the more expensive option, we do recommend going through with option 2 just because it aligns best with the membership's interest in cultural teachings and knowledge sharing.
So to recap, I will reiterate our final recommendations and the associated estimated cost of our proposed management plan. So here is just the restoration and management timeline, with it beginning in the summer of 2025 with the site cleanup, as NBAPC has already been interested in fulfilling that quote with the construction company. And this is where we would really recommend that select harvest of species that are not due to fare well in increased climate scenarios. Fall of 2025, after the site has been restored, then the membership can commence low-impact activities. Following in the spring and summer of 2026, this is where we would recommend the installation of the medicine trail, as well as the fill planting operation of red oak to really just use up the open canopy spots in the forest. And then into the future, 2027 to 2030 is where we would recommend the reconstruction of the essential infrastructure to host the AGMs in summer camp in future years. So overall, here is our cost breakdown, starting with social. The social costs are associated with the signage and security cameras, as well as the cleanup, which is the approximate $23,000 for the demolition and waste removal, as well as the boundary confirmation. The forest cost is associated with the portable sawmill, as well as the red oak saplings, and then the medicine trail is the signage and the benches, for an overall estimated cost of $30,000. Although NBAPC has already set aside some funding in order to help out with these costs, any residual funding that is needed in our resource cache that we compiled from our social survey, we did outsource some funding opportunities to really help with this cost breakdown moving forward. So in summary, just to go over our final recommendations, for social, we did go with option 2, the inactive precautions, just to overall increase security, but we do usher them to phase into the option 3, the proactive approach in the next 2 to 5 years to rehost the summer camp and AGMs. For the forest recommendation, we do recommend the low impact harvest and fill plantation, just to remove those species that are not deemed to do well in climate change and refill those spots with the climate resilient species. With wildlife, it is the no further action option, although we do usher them to reconsider in following years, as well as the medicine trail, which is the longer trail of the two that sees more of the property, as well as the implementation of benches and signage to just aid membership overall. And that is everything we have for you today. I'd like to take the time to thank Brad for being here, as my anxiety made me forget in the beginning, and we greatly appreciate you being here. And I'd like to invite the rest of my group up to answer any questions. Brad, just if you have any questions, we'd love to hear them.
Overall, I don't have any off the top of my head at the moment, but I want to say great job, guys. We really appreciate the help, and you guys did a great job. Like, it was amazing. We're looking forward to reading the report and seeing what we can actually implement right away.
Thank you.
Thank you.
It's my understanding that the land used to be much larger than they had, and you talk about land acquisition in terms of the cost. Is there any, do you know if there's any mechanism to go back to the federal government and see if they could, now that there's going to be a bigger presence, to go back and ask for that back in the original?
Yes, that is something that we were talking with Brad about at the start of the semester. That is a process that they can go through. You can pay for this, but yeah, with the NBAPC, this is something that they could apply for.
Annabelle?
So you're talking about planting, still planting red oak species, and
And I noticed that in the wildlife, you also mentioned that one of the number one uses of the property is white-tailed deer. I was wondering if you had anything in mind to prevent the white-tailed deer from overbrowsing the oaks, because I know they love it.
We initially haven't considered that yet, though that is definitely a consideration, considering there's like a lot of white-tailed deer species on the property already. I believe that right now, our main objective and what we're trying to focus on was obviously the social section, with the wildlife section being a little bit at the background because it wasn't something that we deemed necessary right up at the front. But moving forward, when there's that acquisition of land, and also within the following years when we do decide to plant, then I think that should be a consideration for sure.
Tom?
You might have said it, I might have missed it, but what is the actual tenure, or who owns the land? NBAPC?
Yes, NBAPC. It's a leased land, but NBAPC is the lease.
So they don't own it, they lease it?
Yes, they lease it.
From who?
The Crown.
The Crown.
From the province?
Yeah.
Okay. Do you know anything about the tenure or the security of that lease? Like how long the lease is for? Is it automatically renewed? No, you're right.
So there is, I guess, per bounds in which they have to upkeep in order to keep the lease, and so I believe the lease is able to be upkept for many years as long as they're in compliance with those regulations.
Okay. And what about the surrounding adjacent properties? Who owns that?
I think they're still also Crown land, although there are certain forestry companies that do have leases on them to do harvesting on them.
Okay. I mean, that's kind of why I was interested in what I was getting to. You know, you do have a small land base, so it may limit you in terms of what you can do for wildlife. But if you have reasonable confidence that, you know, like there's not going to be a residential development, or like it's always good to be aware with these properties of what's adjacent to them, what's going on, what's likely to happen, what's unlikely to happen, because that can fit into your planning, right? You can't control it, but you can for sure use that information to, you know, actually meet some of your objectives.
On the right side of the property, the forest was harvested in the last, I want to say 10 to 15 years, but on the left side of the property, it has been unharvested. So there would be more, I guess, opportunity on that end than the...
Okay. Still on the wildlife thing, how did you calculate those percentages of the large animals that you saw?
Those were based off of the camera traps. We just counted every single species there, and then those were just added up into, I guess, the respective species.
Okay.
Sorry.
But your total number that you're dividing from is every time a photo was taken, right?
Yes.
Okay, so it's probably just one lake that you took 8 pictures of, right?
Yes. I guess we counted it, though. It's like every single time it was, like every single time the camera flashed 5 pictures. So for one lynx in 5 pictures, that would be one lynx. But then that same lynx came up at night 2 weeks later. That was still the same lynx, but technically a second count, if that makes sense.
Anthony?
I see one of your recommendations was, or your forestry recommendations was partial cutting and then a fill plant red oak. So does your forecasting, does that support that management scenario? And if so, how so?
Do you want to take this?
Yeah. Initially, when we modeled with picus, it wasn't predicted. The red oak that's there was predicted to not fare so well. But then once we implemented it in, as we added it as a fill plant, I don't really remember.
Yeah, I feel like we also didn't plant very much. I think we planted around 200 stems per hectare. It's also pretty dominated by softwood species, so I feel like that would probably impact, the seedlings and their ability to kind of grow in the beginning, which is why we suggested to kind of plant them in areas where they would just there would be an already opening, but over the years they would have to be kind of maintained, they'd have to be checked up on. But I feel like just because we've planted so little, the Picus model didn't really show too much. But I feel like they would be okay with the yearly done.
Well, and that's why I was picking on it, just because if you look at the trajectories, it doesn't seem to be doing that well. But some of it could be because you planted very little, or you have other species in the community that are competing with the red oak. So if you want red oak, which is considered to be a climate change, these other species, then you may also have to consider controlling that competition of those nasty red maple.
I should have mentioned this 5 or 6 months ago, but Mangos, the director of the Wilson Center and a professor in our faculty, years ago when the Truth and Reconciliation Committee was meeting regularly, was very keen on building a brown wooden Indigenous students center just below Neighboring Halls. I think he would be super excited about being part of building a new center and potentially having the community involved in doing that. So might just throw it in there. He's well connected with the kind of building industry and funding agencies and so forth that could potentially help facilitate making something like that happen. One last question, and on that issue, the vandalism is really worrisome to me as a sociologist. Like, you have plans for, bringing in a lot more infrastructure, buildings, equipment, sawmill, et cetera. So I know you sort of talked about trying to create better community relations, but is there anything more to be done around that? Or it seems a risky prospect to build a whole bunch of new infrastructure if there's a long history of infrastructure being damaged?
I think that there's kind of like a multifaceted approach to curbing the vandalism. First being the boundary confirmation and instituting no trespassing signs along the boundary. The next being sort of an up in traffic on the land because of cleanup efforts and hopefully some events going on there. But we did also suggest sort of like a routine checkup to be done, and some of the details of that, which we discussed in the report, were maybe having a summer student who is like either contracted to go on site every so often, or some of the members discuss possibly like having someone stay in the residency once the lodging is built. So there is opportunities for that, and I think there's a lot of people in the membership who really want to get out there and use that land. So as a result of them being there, that'll naturally decrease the threat of vandalism.
Great, thank you.
I think I saw it correctly, but I think on slide 29 you had tariffs, just as kind of sensitivity analysis. How did you kind of account for that? What went into it?
So for the sensitivity analysis, so your question was tariffs, sorry,
Yeah.
could you repeat it, please, just so I hear?
Yeah, no, just
Thank you.
curious how you account for tariffs in the analysis.
Okay. Personally, based on the report, I'm not sure how much we've accounted for it yet. We still have some to write about. The sensitivity analysis, based on these stochastic events that kind of happen, we obviously rated them and we kind of put most priority on the highest ones, though that is always an issue, always a possibility of something to happen. So we wanted to add it in there just in case, though that's definitely, we don't personally believe that that is like the highest priority going forward.
Additionally, when we ran our sensitivity analysis, it was on the Government of Canada's RCP. So in terms of tariff, as the climate increases and those species that we use for lumber become suppressed, therefore they would cost more money, then that's when tariffs would possibly impact our project. And that's only if we wanted to outsource construction material as well.
Hello everyone and welcome. My name is Gavin Bess. I'm here today with my friend Tim Rankin to present to you our final presentation in 4020. We are part of the David Currie, Gabriel Mallet in partnership with the York Sudbury Charlotte Marketing Board 4020 group. In our team, we have 9 team members, all in our Bachelor of Science of Forestry. Our team members include Sebastian Del Cambre, Aaron Mullen-Heiss, Connor Seeley, Trevor Sayward, Timothy Rankin, Noah Cooper, Riley Ward, myself, and Alex Dolan.
Here we'll be going through a little overview of our management plan and the style of the management cycle. Starting with the scope and scale, we'll introduce our clients, the partnerships with them, and a little brief introduction of the woodlot. Moving on, we'll go into the characterize and value, where we take the goals and objectives that have been set by our clients, and we will implement a comprehensive inventory of the woodlot to analyze its resources at its current state and create a good base for our management plan. We will then take that data and implement it into the model and forecast stage of the management cycle, where we can use Remstock's Woodstock software and to implement a strategic, tactical, and operational plan that keeps climate change and a sensitivity analysis in mind. Using the results of that model and the forecast, we will then take those results and undergo a trade-off analysis for the plan and report section, where we analyze in which scenario suits our clients' needs best. To introduce our clients, we have David Currie and Gabriel Mallet here, as well as we have the York Sunbury Charlotte Forest Product Marketing Board, specifically working with Anne McKnight, the Silviculture Manager, as well as the Department of Natural Resources and Energy Development of New Brunswick. A brief introduction to our woodlot it's located in Burt's Corners, New Brunswick, which is approximately 35 minutes or 35 kilometers northwest of the University of New Brunswick.
Our woodlot is a total of 279 hectares. 112 of these hectares are in forest area, 130 are harvested area, and 37 hectares are fields within the southern portion of the woodlot. The Little Fork stream flows throughout the woodlot, and the woodlot is used for recreational purposes of ATVing and side-by-siding, along with hunting of white-tailed deer and ruffed grouse. In 2022, there was a 74-hectare strip cut conducted by AV Nashwaak. The total volume from the strip cut was around 9,400 meters cubed. The following year in 2023, AV Nashwaak also did a clear cut just west of the strip cut, and there was 11,450 meters cubed harvested during the clear cut. Within the woodlot, we have a Royal Canadian Legion cross. The cross is located between the two cuts and was originally placed by the British Empire Service League. We believe the cross to be placed between 1925 and 1960, as the name was changed to the Royal Canadian Legion in 1960.
As Gavin mentioned, David and Gabe have shown interest in hunting white-tailed deer and ruffed grouse as a food source, and so therefore we'd like to continue for them to be able to have that tradition into the future. Therefore, an assessment of their current potential habitat levels, as well as their food accessibility across the property, using our inventory results will act as a base for the management plan to ensure their habitat is consistent. Moving into our environmental objectives, we would like to improve the ecosystem services and functions as a whole by minimizing the erosion effect and maintaining a 30-meter stream buffer with the Little Fork stream, as well as increase the amount of climate-resilient species through fill planting and removal of undesired species. For the purpose of this project, the undesired species are species that are projected to decline dramatically in the future. Just for kind of stating some importance of this project, as we've seen today, the projection of balsam fir into the future is expected to decline in New Brunswick. Looking at an RCP level of 4.5 from 2026 to 2066, we can see a decrease in balsam fir composition compared to 2006. When applied to an RCP level of 8.5 from 2066 to 2100, we can see that balsam fir has been virtually wiped out of the province. By implementing more resilient forest species, we are able to, and managing competition through pre-commercial thinnings over the course of 15 years, we can then help implement self-sustained stands to create a desirable, resilient composition over the course of 25 years.
Moving on into the stakeholders of our project, the two main stakeholders for our woodlot are the landowners, David and Gabe, so they hold a financial power of the woodlot, and the Forest Marketing Board, which also holds the financial power of the woodlot. These two groups, the landowners group was to be classified as unorganized, while the YSC group is classified as organized. Within the woodlot, we have 15 delineated stands via LiDAR. I'd like to thank Steve Sears from the New Brunswick Southern Marketing Board for delineating the stands for us. Moving on to our forested area species composition, we have a total of 518 stems per hectare of balsam fir, equaling out to around 35% of the total species comp. The next leading species is poplar at 25% or 360 stems per hectare. Moving forward to that diameter, we had an average diameter of 14.3 centimeters throughout the whole woodlot with a max diameter of 21 centimeters in stand 7. Diameter is an important attribute as it gives us an insight of how the trees are growing within the woodlot. Basal area was our next results within the forested area. Our average basal area was 40 meters squared per hectare, and the stand with the most amount of basal area was stand 8 at 100 meters squared per hectare. Basal area is the amount of space that each tree takes up on the ground. That is why it is in meters squared, not meters cubed. Finally, moving on to the volume of our woodlot. You can see the volume of our woodlot. Our average volume across all stands is around 330 meters cubed per stand, with stand 7 having the largest at 780 meters cubed. This is the total amount of standing timber within each stand.
All right, and moving into the results of the clear-cut area at its current state, we can see that the regeneration density, so the trees that have been growing since the recent harvest, primarily consists of poplar, red maple, and gray birch. When looking at the regeneration height, this gives insight to the stage of succession that the forest can be in. And as you can see, the two tallest species noted were the poplar and white spruce. This gives insight to how it's going, as poplar is a pioneer species, meaning it's one of the first species to pop up after disturbance. Looking into the clear-cut residual density, these are trees that have been retained post-harvest as they serve wildlife purposes and seed trees as well. As you can see, we retained balsam fir and red maple as the majority of our residuals to just help continue with the succession. And moving into the coarse woody material by decay classes within the clear cut, we're representing these decay classes through 1 through 5, 1 being the wood on the forest floor is fully intact, 5 being the wood is fully decomposed and on the forest floor as well. The importance of coarse woody material for this purpose is that as the wood decomposes, it becomes a host for insects that the ruffed grouse eats. As you can see, the majority of coarse woody material in the clear cut was in class 3, followed by the next highest in class 1. This aligns with the recent history of the woodlot as the clear cut was performed in 2023. Looking into ground vegetation in the clear cut area is important as well, as vegetation can be served as an indicator species for site productivity, health, and post-disturbance levels. As you can see here, raspberry takes the cake on having the most amount of density here, which also aligns as raspberry is an early successional species.
Moving forward to our strip cut results, as I mentioned previously, the strip cut is 74 hectares and was conducted in 2022. The species comp for the strip cut area was 54% poplar at almost 34,000 stems per hectare. I know that may seem like a lot, but at times when we were doing the inventory, it felt as though you were swimming through the poplar. The next leading species was red maple at 8,200 stems per hectare, around 13%. Moving on to the height in our regeneration, the height of our regeneration in the strip cut. Again, poplar was the leading species with an average height of 2.3 meters. This means that poplar is outcompeting all the other species within the strip cut. The residuals in the strip cut were found more frequently as they were left behind on purpose. We had mostly balsam fir at 44% or 44 stems per hectare, followed by gray birch at 18% and 18 stems per hectare. The coarse woody material within the strip cut was also found within K class 2 and 3, similar to the clear cut. This makes sense as the clear cut as the strip cut happened not too long ago, and the wood has not had time to break down yet. It's important to note that the coarse woody material is important for insects that grouse like to eat. That's why we took account of this within our inventory. Finally, moving on to the ground vegetation in the strip cut, we had 64% raspberry, again, leading species, same as the clear cut. This makes sense, as Tim mentioned previously. It's a pioneer species that thrives off disturbance. And we had over 20,000 stems per hectare of raspberry. The next leading species was New York fern at 12%, or 3,600 stems per hectare.
All right, so taking all those resources that we gathered and using that in ArcGIS, which is a mapping software, and using it in comparison with the parameters of rough grouse habitat, we were then able to use definition queries to predict areas that rough grouse potential habitat would be. As you can see here in the map, we have stands 2, 3, 4, 9, and 13 that represented potential rough grouse habitat. It's also important to note that this is just a prediction of a representation, and that they can be found elsewhere as well. Following the same process, we can map out the overwintering white-tailed deer habitat as well. Using their parameters and crown closure species mix, we can also determine that stands 9, 13, and 11 also suited deer in the overwintering stage. Using information from UNB, we were also able to identify forested wetlands within the property. This is key for improving the ecosystem services and functions, as wetlands, they are important for stream health as they help with sediment filtration. They also help with nutrient and moisture regulation. They also serve as edge habitat, nesting sites, overwintering sites, and a good food source, as lots of herbaceous species can grow there. It's also important to note that if any management does occur within this area of the wetland, that all operations must follow the WAWA, the Watercourse and Wetland Alteration Law, and also the New Brunswick Clean Water Act, as well as any other relative legislation.
Moving on to our operations plan overview, we've broken down the operations plan into four different sections. First, I want to start off with the resource inventory results, which we just presented to you. These results are crucial as we take into our next step of strategic level planning, which we model and forecast the future of the woodlot. We've chosen to do 3 separate scenarios within the woodlot: a status quo scenario with no interventions at all, a maximizing stumpage value scenario, which our main goal is to timber production, and maximizing stumpage value while maintaining wildlife. We then take these results and look for insufficient stands that are unstocked with climate resilient species. Next, we go into our tactical planning horizon. This is where we look into ordering seedlings, assessing the site, and assessing boundary lines within the woodlot. Then we're going to our operational plan, which we recommend happens in 2029. This is where we're going to do an underplant within 4 different stands of the woodlot of red oak, yellow birch, eastern white pine, and red spruce. As I said, we did 3 different scenarios within our modeling, and we used Woodstock optimization software to model the future of our woodlots. Status quo is no interventions at all. Although this may not seem as an important scenario, it is, as though we need to see what the woodlot will do after nothing happens at all. This can be a management strategy if it meets all goals and objectives of the woodlot. Our next scenario was to maximize the timber value. We mainly focused on timber production on this, and we had no wildlife constraints when doing this scenario. Finally, our third scenario was to increase stumpage value and maintain wildlife habitat. We focused on climate resilient species and maintaining all the habitat for food, all the wildlife habitat and food availability for wildlife. Going on to our constraints of our 3 scenarios, status quo has no constraints as there's no interventions at all. Looking at maximizing stumpage value, our main priority was to maximize the timber production, and our constraint was limited interventions may occur as the landowners do not want to do any harvesting. Finally, looking to our third scenario of increasing stumpage value while maintaining wildlife, we have 3 constraints. There's being total wildlife area may not decline from 2024 levels. Stumpage value must increase from 2024 levels, and no harvesting may occur within the forested area. Going into our operational plans costs within the next 5 years of our woodlot, we recommend that we do an underplanting within stand 9 that is 2.6 hectares of underplanting of red oak, yellow birch. Stand 8, we're going to do we recommend 3.4 hectares of red oak and yellow birch underplanting. Stand 7, 1.4 hectares of eastern white pine and red spruce planting. And stand 5, 1 hectare of red oak and yellow birch planting. The total cost for all planting costs and seedling costs is around $29,000. Breaking down the costs even further, you can see we have two gap types for underplanting. I should mention that underplanting is when we go into stands that are in stem exclusion stage, meaning that the stems are starting to die within the canopy, opening up light to the understory. Then we go in, we recommend planting within these gaps to fill them with climate resilient species to change the forecast and future of the woodlot. So for eastern white pine and red spruce, the minimum gap size is 0.28 hectares, and we want a gapping stock density of 700. We're going to have 500 eastern white pine and 250 red spruce for a 70-30 mix. The reason why we have 250 red spruce, not just 200, is because the bundles are only sold in 250, and they're from Strathclyde Nursery in Cape Breton, Nova Scotia. The total cost per hectare of planting eastern white pine and red spruce is $589. Moving forward to the red oak and yellow birch, the minimum gap size is 0.13 hectares. We're to do an 80-20 of red oak, 80%, yellow birch, 20%. We're looking at planting around 325 trees at each gap, and we want to do a 365 with a 300 red oak and 65 yellow birch. The reason why we're doing so much more red oak than yellow birch is the price difference. So you can see one red oak seedling is $1.35 versus one yellow birch is $3. These seedlings are coming from Springfield Nursery in Currie, New Brunswick. I probably butchered that. The softwood species, like I said, are coming from Strathclyde in Cape Breton, and they're only 22 cents a tree. So it goes out to $3,200 per hectare of planting hardwood species. Breaking down the cost of funding from YSC to planting the woodlot, we can see that the total cost is around $30,000. YSC contributing with funding of underplanting can contribute $14,000, with the remaining $15,000 being the landowner's cost.
All right, so implementing scenario 3, we can take a look into 25 years into the future at 2049, which brings us to the woodlot's composition by area. It's important to note that this area is now, the woodlot is now one, and it is not the clear-cut, strip-cut in the forested area. It has grown into one forest now. Looking at here, we can see that the majority of the woodlot is now of tolerant hardwood, and 47% and 26% is intolerant hardwood, with the remaining being a softwoods mix. It's important to note that keeping the softwood mix in the forest is essential for keeping uncertainty and risks down if there was an infestation that went through, and just ensuring that there is habitat for deer and grouse as well. Looking forward into the overwintering white-tailed deer habitat projected over the course of 25 years, we can see that it averages around 90 hectares over the course, with a slight dip. Doing the same process for ruffed grouse overwintering habitat, we can see that the ruffed grouse habitat remains somewhat level with a sharp increase in 2046. This is due to a forecasted thinning that has been implemented into the scenario to allow for regeneration in those self-sustained stands. Taking our results from our model and implementing it into a trade-off analysis, we can see that scenario 3 of increasing the stumpage value and maintaining the wildlife habitat area was the best scenario was the best scenario in relation to our clients' needs, as we were able to divide it into social, environmental, and economical, and give them a rating from 1 to 0, with partial being 0.5. The maximum stumpage value and wildlife habitat resulted in 75% compared to the 56 and the 63 of status quo and maximizing stumpage value, which is why we just decided to not move forward with those two. Keeping in mind uncertainty of things that can impact our woodlot and the management plan that we have in place are things like pest infestations such as the spruce budworm, wind throw events, fire, drought, tariffs, and the availability of funding possible to complete these operations. Taking a little closer dive into the pest infestation of spruce budworm, we felt that this one had the most risk to our woodlot as it had moderate to high. As you can see here, that a pure balsam fir stand has a much higher rate of mortality compared to a mixed balsam fir hardwood stand. We wanted to just kind of, again, reinstate the importance of having those climate resilient species in there as well and having the diversity. Because right now our forested area is made up of 35% balsam fir, and we would like to implement more climate resilient species, and having that mixed species means the susceptibility of and the spread of the spruce budworm can be limited.
Finally, moving on to determining the accuracy of our management plan, we've broken it down into short-term and long-term goals. Our short-term goals for social were to assess the current game species availability. We achieved this by doing the inventory within the woodlot. The second one was to assess the current game species food availability. We also did this by assessing the woodlot and doing our forest and strip cut and clear cut inventory. Moving on to environmental goals, we wanted to reforest the clear cut and strip cut area into climate resilient species. As the woodlot is growing back with poplar and mostly red maple right now, we have achieved this because poplar and red maple are projected to do well in the new climate. Economical goals, we wanted to do a pre-commercial thin in year 2040. Fortunately, we did not complete this. Our model suggested the thin to happen in 2049. Looking at YSC funding, we want to do minor silviculture interventions with YSC funding from this. We did achieve this under planning as a minor silviculture intervention, and we hopefully will receive funding from it. Looking into our long-term goals of wildlife habitat, maintain and increase the wildlife habitat within the woodlot. We did partially hit this as the white-tailed deer overwintering habitat went down a bit over the woodlot, but not that much to make a whole lot of difference. Looking at maintaining and increasing nested overwintering areas and eastern white cedar stands within the woodlot too. We did complete this as we found where the eastern white cedar was, assessed it, knew that it was in good condition, and there's no reason why it shouldn't be there in 10, 20 years time from now for the deer to use its overwintering habitat. Finally, looking into environmental goals, we wanted to protect the streams and wetlands with buffers. We're going to be doing no harvesting or no interventions within these, so we partially complete this as we aren't doing anything, but we're not going in them either way. Finally, looking to climate resilient species as an increased value. We did do this partially as we only did 5 stands of planting, so that's why it's partially and not fully completed. In conclusion, our recommendation for David and Gabriel is to underplant those 4 stands that we said briefly in our operations plan. Our PCT is planned in 2049 for the strip cut and clear cut area to increase growth in it, but will have to be reassessed further down the line to make sure that the stands still qualify it. I'd like to thank David and Gabriel for letting us use your woodlot for 4020. It's been a pleasure going out there, and I'd also like to thank Ann McKnight for all the insights that she had within the woodlot management plan. It wouldn't be possible without her at all. I'd also like to thank everybody that's a part of 4020. Our whole group did a great job, and we couldn't have done it without them. I wouldn't have had any other group if I could choose. It was awesome. Had a great time out doing field work in 4022. It was awesome, and Jason was so much help, and honestly, it was just a great year. So thank you so much. Start off with David, Gabriel, and Ann if you guys have any questions.
I'll start with mine. You guys did a good job. There's a lot of data there. I'm really looking forward to having a closer look at it once everything gets settled down again. You guys mentioned the fitting, and I know there could be a lot coming on there. You're talking about 24 years in the future before, and maybe I missed it. Why were you putting it off fitting that long?
Sorry, that was actually incorrect. It's about when the stand reaches age 12, I think, which is in 10 years.
Okay, you said something about 2049.
Yeah, it was misinputted there.
Oops.
But I was just here by that time it's been committed over.
Yep.
And great call.
Yeah.
So, yeah, once it gets up there around, maybe 4, 5, 6 meters, it's not going to be so I think it'll be a lot sooner than 2059.
Yeah, in the schedule that Woodstock created, it was, I think it's somewhere in 2035 or 2036 is when it's actually gonna occur. It was written there.
Okay, no, I know I heard something like that. Yeah, you got a lot of software to do.
Yeah.
And that is predicted to do well in the future. Software?
That's what we determined, yes. Ryan?
I had 2 questions about stumpage. So one of your scenarios was increased stumpage but no harvest. Why would I care about stumpage value if I don't want to harvest?
We looked at increasing stumpage value because one of the goals of David and Gabriel was to increase the value of the woodlot. They weren't necessarily looking at timber products like studwood or pulp, or the market value. They wanted to make the, don't want to say make the trees look better, but improve the function of the ecosystem and trees. And I believe Riley said it was better to put it in woodstock as increased stumpage value than timber production, and it made, right, Riley? If you want to carry on with that?
The reason that we increased the stumpage there was just in case there was like if David or Gabriel ever needed to, cash in their investment on the property, decreasing the stumpage value by like 25% or something like that would not be a good option for them. So increasing the stumpage by roughly 10% was what we wanted.
Okay, and then on that, this land seems like it wants to grow upward. So you had some undercutting, but I think you were showing your stumpage was going to grow by like 40, 50%. What was driving that?
We didn't have any grass in there for stumpage, but our stumpage grew by about 10%, from about 18,000 to 20,000.
What was adding value to the forest?
So the value of the stumpage, what's that in the forest?
How are you growing the value of stumpage over time?
So the value of stumpage is growing over time through basically just those strip cut and clear cut areas, just growing out, just grew value to the woodlot through like hardwood pulp from the hardwood that we were planting in there in the schedule, and then the intolerant hardwood pulp as well. The balsam fir, studwood, and sawlog decreased significantly.
So it's kind of more lower quality volume versus
Correct.
less high value?
Yeah.
Anthony?
What was the planning horizon?
The planning horizon was 25 years.
And so you had created a strategic plan, and then you talked about an operating plan. So what is your operating plan? Was it being guided by the strategic plan?
Correct, it was, yeah. So we did, we took with the the output that Woodstock gave us for the schedule, and then we compared what it was telling us to operate on, and we compared it to what we have, and then we just used the requisite hectares we needed, selected those hectares, and then added that action to it. And we lumped them all within like a similar time period because it was telling us to do it over like in the 5-year plan, it was telling us to do it between like year 2, 3, and 5, and so we decided to just bring them all together and make it cost more efficient.
What about, so in your strategic plan, did you have like 5-year time periods?
Not in the strategic plan.
What was the resolution in your strategic plan? Your horizon was 25 years, but those planning period, what was the length of those? Do you recall?
I do not recall. I think the planning periods in Woodstock were just 1 year. Like you mean like when it switches over to
the time steps.
Yeah, it was 1 year.
Just in Woodstock, then when you were using it, because you had some constraints about wildlife, how did you account for wildlife? What did you do in Woodstock in order to tell Woodstock what wildlife habitat was in order to account for it?
So yeah, we made those area queries or whatever, they're not queries, but definitions, and Tim inputted the rough grouse and the white-tailed deer ones. So I can't speak to the exact input.
What was it for grouse?
I don't remember the exact values of it at the moment, but I do remember taking the values of what they needed for overwintering for their nesting sites. So species that they enjoyed, specifically yellow birch was in there, and some softwood species. Taking that and ensuring that there was no, kind of in comparison with the density in the basal area of them, ensuring that there was no declining yield. Yeah.
Just last question then.
Yeah.
And then for your, this is kind of critical, but for your yield tables, the yield information you're using this stuff, where did you guys derive that?
I derived that from the Nova Scotia government growth and yield system, the software.
Yeah, okay. Warm my heart to see you.
We did it just for you. Tom?
First of all, I'd like to comment on the impressive display of plaid in your opening. And the lack of plaid now, so you know how to dress for the occasion. That's good. So what do grouse like? What do they need?
Poplar. They like poplar as a food source and for nesting. They also use coarse woody material, as we mentioned, for both food sources and also larger pieces that aren't decomposed they use for nesting sites. That's why coarse wood material was kind of a big part of our forested and clear-cut and strip-cut results.
In speaking to Graham also, from what we understand, they're like there's like a transition areas between like a taller poplar stand and like sort of edge, and then that like older like tolerant softwood and intolerant softwood stand.
Right. So, and the same question for deer. With deer, do deer like the same thing as grouse or not?
No, so for deer, I know on our definition queries for habitat, lots of cover, and then softwood composition, I think it was around 60%, 60 to 70% softwood composition.
So they're fine in edge, right? They like some edge?
Yeah, edge habitat too.
Is there like a ratio of like how big those clearings should be and how much?
Not that we have determined, no.
Okay. So what I'm getting at is, particularly with the strip cut and the clear cut areas, like do you have like a spatial plan that is going to, where those are kind of uniform now, in the future to have them not be uniform? And to basically be the types of habitat that your desired species want.
Yeah, so in the Woodstock model, we inputted the definition queries that we got from people who went and read the papers, and the Woodstock model uses a solver to try to optimize for that habitat. So in our 25-year strategic plan, the PCP and the fill planting is geared towards increasing the definition of that habitat. And it does create uneven stance in that with the PCP and then the planting.
Okay. Good. I mean, I think you have a unique medical problem. I made comments in your interim proposal around this, that the default is to like, we want to grow big trees, right? And this may not be the best strategy for the target species of wildlife that you're after, so nice adjustment. So I was looking for it.
Any other questions?
Wait a second.
Huh? Do you want to present? You want to introduce us? No, I think we're good. Thanks, Gavin. I don't forget. We'll just let the energy chill. Testing.
Testing.
Can you hear us?
Anyone hear
Hello?
us? Yes? Good?
How
Fantastic.
close is too close?
All right. All right. Thanks, everybody, for being here. Thanks for sticking with us to the end. Best for last. My name is Chloe. This is Helen, and we're going to be talking about our restoration plan that we've developed for Upper Neill's Flats.
First, I'd like to acknowledge the land. Upper Neill's Flats is situated on the unceded territory of the Wolastoqey along the Nashwaak River, where the land and water hold cultural and ecological significance. The Indigenous nations and their territories are governed by the treaties of peace and friendship, which did not involve the surrender of lands, waters, or resources, but instead recognized Indigenous title and established rules for ongoing relations. We acknowledge and respect this territory and strive to be responsible treaty partners.
All right.
We're a team of 8 individuals from UNB's Faculty of Environmental Management and Forestry. This has been a multidisciplinary effort with excellent skills from the forestry, environmental, and wildlife faculty. And I'm really grateful to have Anna Bowers, Tim Gamey, Emma Golden, Suzanne McKinnon, Jillian McMillan, and Aidan McNeil with us. So here's a quick overview of what we'll cover today. We'll talk about the context of the project, key species at risk, goals and objectives, our results, 3 management scenarios that we evaluated, as well as our final recommendations and the trade-offs that they provide. Our client is the Nashwaak Watershed Association. They're a nonprofit, non-governmental organization that was established in 1995. One of their main goals is to carry out riverbank and floodplain restoration projects where possible. Today, we're lucky to be joined by Tanya Germain, the Restoration Program Coordinator, as well as Ian Lodge, the President of the Nashwaak Watershed Association. Thank you so much for all of your help throughout this project. The Nashwaak Watershed Association has been working with the City of Fredericton to create a greenway along the banks of the Nashwaak River, from Marysville to the confluence of the Wolastoq and Nashwaak River. This is where our property comes in. Upper Neill's Flats is an 8-hectare property located on the north side of Fredericton, on the banks of the Nashwaak River. It's owned by the City of Fredericton, but stewarded by the Nashwaak Watershed Association. This land was historically silver maple floodplain forest, but in the early 1900s, it was converted to agricultural field for haying. Much of this property is considered provincially significant wetland, meaning it has important ecological value. So why is Nashwaak Watershed Association so concerned with restoring silver maple floodplain forests? As I said, the client is laying the groundwork for the creation of a greenway along the banks of the Nashwaak River. Floodplain forests provide natural flood storage, reducing downstream flooding risk. Silver maple stands stabilize riverbanks and reduce erosion. These forests filter runoff and improve water quality by trapping sediments and nutrients. They offer critical habitat for a wide range of species, including species at risk. And restoration enhances climate resilience and reconnects riparian corridors for important wildlife. This property is divided into 2 major habitats. In the center of the property, making up about 4 hectares, is the Old Field. On the northern, eastern, and southern sides of the property, there's silver maple forest, which is bounded by a dense thicket of glossy buckthorn edge, which we'll talk more about later. The purpose of this project is to develop a restoration plan that will address species of interest habitat loss, challenges with tree planting on nearby similar properties, bank erosion, the spread of glossy buckthorn, an invasive species, as well as climate change threats. Now I'll turn to Helen to talk about wildlife on the property.
So wildlife on the property consists of generalist species such as deer, beaver, and porcupine. They are adaptable. They have adaptable diets and habitats, and therefore are considered pests due to the tree damage they inflict on planted trees by herbivory. Species at risk of concern on the property are bobolink, monarch butterfly, wood turtle, and bank swallow. So for bobolink, they are a threatened species under the Species at Risk Act and are recently considered special concern under COSEWIC. They need open grassy areas of greater than or equal to 200 meters from a forest edge or a hard edge for nesting. This nesting habitat, however, cannot be maintained unless annual haying occurs. As for monarch butterflies, they are endangered under both SARA and COSEWIC. They require common milkweed for breeding, and there are patches of milkweed present in the northern edge of our field. Wood turtle is threatened under SARA and COSEWIC. They need undisturbed forest stream edge habitat due to the fact that they like to bask, and they do not like dense enclosed canopy. They are active during spring to fall, and so our recommendations aim to avoid habitat disturbance during this time. Finally, bank swallow. They are threatened under Sarah and Kosiwik, and they have an unfortunate tendency to nest in eroding vertical riverbanks. They forage in nearby open fields, such as the ones present here on Upper Neill's Flats, and they are, of course, sensitive to erosion control efforts if they occur directly in their habitat. As for the project goals, I'll be going through each of them individually, but broadly, we have environmental, economic, and social objectives to be met. Our first goal is forest assessment and restoration. We aim to establish and to maintain sustainable silver maple stands. This includes the healthy and stable regeneration in the understory, in an effort to support a diverse range of wildlife species with a focus on species of concern under this habitat type, that would be wood turtle. For our second goal, old field and assessment, as well as the feasibility of having forest edge expansion, we aim to create a pathway for natural succession within the old field, which would trying to minimize impact on field-dependent wildlife such as bobolink and monarch that are present on the property. Our third goal is glossy buckthorn control, as it is an aggressive invasive that takes up approximately a hectare on the property. We aim to decrease the presence of glossy buckthorn, and we find this critical to encourage natural succession of the forest and to restore native species as well as critical habitats. Our fourth goal is erosion mitigation, which is a large portion and is of interest to the client. We aim to assess the rate of erosion and to see if we must maintain or hopefully increase riverbank stability to improve water quality within the river system while also preserving habitat for bank swallow and wood turtle. Our fifth goal is long-term monitoring and climate resilience. We aim to monitor for and to adapt restoration strategies in response to ecological changes and climate impacts over a 25-year scope period, which will be the extent of our planning. As for the sixth goal, this is our economic objective, cost-effective management. We aim to develop and recommend restoration strategies that are financially feasible and prioritize quality over quantity. Our seventh and final objective is stakeholder engagement. We will design and adopt a tree program as a future initiative that would encourage stakeholder collaboration with the public and possibly other NGOs while maintaining reforestation efforts. Now I'll pass you back to Chloe.
All right. Based on those objectives, we did extensive surveying from September to November. During this period, we spent many long hours on the property conducting various ecological assessments. These included 7 forestry plots, 34 vegetation plots, 14 tree cores, 2 riparian assessments, 7 wildlife transects, 12 soil samples, 1 stream bank assessment, and 136 quadrats. Based on these results, we found some significant things about the forest. All 3 stands were dominated by silver maple, followed by white elm. On average, these trees were healthy with an age range of 40 to 60 years based on our tree cores. This shows that the property has a longer lifespan than we initially anticipated, as silver maples can live up to 130 years. We also identified 3 key threats to the forest. The first was low regeneration. At each of our regeneration plots, we counted how many seedlings were regenerating within the understory and found that when we extrapolated this information, there was only 166 seedlings per hectare. A healthy silver maple forest will have 500 to 1,000 seedlings per hectare. So this shows that regeneration within the property is very low. We also found significant deer, porcupine, and beaver presence. As you can see from the photo over here, later in the season, we found many of our white elm to be girdled or cut down by beaver on the property. This poses a significant threat. We also found glossy buckthorn was very high in all of our forest plots. It was present in 90% of them, with an average density of 17%. I'd like to take a moment to address why glossy buckthorn is a threat. It's an aggressive invasive shrub that's native to Eurasia. It's especially prominent in the forest edge. This species is known to outcompete native tree seedlings because of its shade tolerance and rapid and dense growth. It also reduces biodiversity by creating monocultures, which suppress native herbs and shrubs. It decreases food availability for wildlife. It does have berries, but they are of low nutritional value as compared to native species in New Brunswick. And it depletes soil nutrients through the dense networks of roots that it creates. As for the old field, we found that grasses and reed canary grass dominate. Based on GIS data, we found that less than 0.2 hectares of viable bobolink nesting habitat exist on the property, which is a lot lower than we originally anticipated. We also found that there is approximately 50 square meters of dense milkweed patches to support monarch butterfly populations.
So I'm going to talk about water, erosion, and soil. As for water, the water quality data was provided to us by the client. When we extrapolated the data, we found that all indicators were within normal ranges and water quality was therefore healthy and or stable. As for soil, we took 12 soil samples across 3 soil types: forested area, field, and seasonally flooded areas. These samples were sent to the PEI Analytics Lab to be tested for nutrients and carbon levels. Results showed that soils were typically quite acidic, and there was a diverse range of carbon levels. It's also important to note that in seasonally flooded areas, carbon storage is expected to be lower relative to non-flooded areas. Now I'm going to talk about erosion. This is a figure. It is a collage of historical images dating back from 1951 to present. Due to unavoidable GIS georeferencing issues, we were only able to get the last 25 years with certainty. But within those 25 years, we can say with confidence that under a meter of soil was lost solely along that riverbank, which affects bank swallow. As for the rest of the property, because we were limited with our historical imaging, we used the revised universal soil loss equation, which is a GIS tool that calculates the expected soil loss in a year. So we thought that the threshold is that if there was less than 6 tons per hectare per year, this would be considered low risk and very little erosion. What results showed, and this is for the erosion of the entire property, not just the bank, showed that 0.0427 tons per hectare per year are expected to be lost based on metrics such as slope and soil loss. So it's considered to be negligible. Now I'll pass you back over to Chloe.
All right. Based on these results, we developed 3 potential management scenarios that our client could choose to adopt for this property. The first is status quo, meaning no intervention. Under this scenario, the old field would undergo natural succession without annual mowing. This would lead to the bobolink losing their nesting habitat in the old field. The glossy buckthorn would continue to spread deeper into the forest, further reducing tree regeneration. As mature trees die and the canopy opens up, there would be no young trees to replace them, leading to the forest being overtaken by shrubs. This scenario would be free of cost, but it doesn't meet the client's objectives. The second scenario that we looked at is based on Sophie Jensen's 2023 management plan for the property. Under this scenario, she recommends a full reforestation of the field. This would result in the direct elimination of open field habitat, which would harm the species that use it, including bobolink and monarch, as well as the bank swallow, who forages for insects in the field. This plan has no management strategy for glossy buckthorn or wildlife pests. It would also directly destroy bank swallow habitat due to the willow staking on the riverbank. We estimated that it would cost about $123,000 to implement. The third management scenarios is based on the recommendation that our 4020 group has put together. First, there would be an intensive glossy buckthorn removal along the perimeter of the field where buckthorn is most dense. Then, the perimeter would be planted with native tree species. Routine pest control would be conducted to protect saplings from herbivory. Annual monitoring would take place to ensure the success of the efforts. We estimate that it would cost around $134,000 for the first year.
So I'm going to take you through the operations plan we developed for the first year. This is a map of our management zones, A, B, C, and D. We are only recommending active management within zones B and C, which are the heavily impacted by glossy buckthorn areas. So that's that purple edge and the little pink section in the southeast corner. So the first step would be intensive manual glossy buckthorn removal. We suggest that if the stem is lower than a meter, they can just be removed by hand or with a small shovel. If the stem ranges between a meter and 3 meters, then an extractigator or a weed wrench would be recommended in order to completely remove the roots and limit the chance of reestablishment or sprouting or shooting. As for stems that are too large to fit in the extractigator, which is approximated to be 3 meters plus, then we would recommend girdling or cutting with a pruning saw. This would happen in the late fall, just before the first frost. We recommend that removing all of the glossy buckthorn that has just been freshly removed just off the property, or we recommend having a controlled fire of it on the property just to limit travel. Our third is an optional herbicide treatment, and we have some options. Given the fact that this is a provincially significant wetland, glyphosate is completely prohibited, and given that it has no selective ability, it has been taken off the docket. As for triclopter, it is an up-and-coming herbicide that is not yet on the market. It is still being researched. However, it is more selective, and it is applied directly to the foliage of the species of interest and dies that way. What we would recommend the most would be the chondrol peat paste, which is a fungal herbicide that is applied directly to girdled or freshly cut stems of glossy buckthorn or whatever invasive you're dealing with. And it is it's good because it's selective, and it is considered to be the most environmentally friendly and human friendly of the 3 options. Our target for this management action is to have greater than 90% glossy buckthorn elimination in the treated areas within 5 years. Next up, tree planting would occur only in Zone B. So along this area, we recommend a composition of silver maple, red maple, white elm, and black ash at 60%, 20%, 10%, and 10% respectively in composition. These are climate resilient species that under the USD Forest Service, given the climate, in the Climate Change Atlas, says that silver maple is one of the most climate resilient trees in North America. Red maple is the most. Luckily, this does make up 80% of the composition. We also aim to restore it back to its original composition, which would be silver maple dominated. Tree planting strategies along that area would be done in a staggered formation, staggered design, with 1.5 meter spacing between each. It is expected that as the trees mature, that space would increase just due to natural mortality. We recommend that the trees being planted are all bare root and within 1 and 2 meters in height in an effort for strong establishment to occur, and so that they reach the 2 meter deer browsing threshold as quickly as possible. Then we would suggest mulching just to further avoid competition. The planting density we recommend is 4,000 saplings per hectare, which would equate to approximately 4,642 trees along that Zone B edge. The target for this action is to have greater than or equal to 30% survival of planted trees within this first year, and that would be considered exceptional, given that they're hardwood species. As for Zone C, we recommend shrub planting. This would be in an effort to increase biodiversity and utilize that freshly disturbed soil from glossy buckthorn removal. It would also act as extra bank stabilization. Red-tipped willow, sandbar willow, and red osier dogwood have been used along the Nashwaak before and are very common and successful in these ecosystems. They would be planted in this area at a 1 meter square spacing density, and this would be considered moderate density. So 1,717 stakes would be planted in the same staggered formation as the trees, alternating between species. The target for this would be greater than or equal to 50% survival within the first year, as they are expected to do better than hardwood trees. And on to pest control.
So obviously we want to protect these important trees from being damaged by deer, beaver, and porcupine. The most effective way of protecting the saplings would be by creating exclosure fencing around the perimeter of the planted trees. However, this is not allowed on the property, so we sought some alternative methods of pest control. The first is plant skid, which is dried blood mixed with water and vegetable oil. It sounds pretty gross, and it elicits a fear-based response in the herbivores, which keeps them away from the saplings. Another recommended method would be tree tubes, which are translucent tubes made of durable plastic. Originally, we were hesitant to recommend tree tubes because we do want to reduce the amount of plastic on the property. However, studies have shown that this is one of the least expensive and most effective ways of protecting saplings, and they are reusable and recyclable. So the Nashwaak Watershed Association could use the tree tubes on other properties after these saplings have surpassed their original height. After the buckthorn extraction and tree and shrub planting, we would set up permanent monitoring plots. These plots would aim to assess the survival rate of planted trees. They would see if any trees are performing better or worse under specific site conditions, and evaluate whether there is evidence of browsing, disease, or other stressors. 5 years into the planting, we would launch a post-reforestation survivability assessment. If this passes the assessment, we would adopt and adopt a tree program in which the public can adopt, monitor, and sponsor native trees. This would increase stakeholder engagement as well as increase the survivorship of the planted trees.
So I'm briefly going to go over the objectives that are met under the recommended plan. So the first would be increasing establishment of native regeneration. Next, promoting survivorship of planted trees with pest control. Decreasing glossy buckthorn in designated areas via intensive manual removal. Deterring press browsing, which is a priority. We would increase forested areas and subsequently wood turtle habitat. We would also increase native biodiversity through a diverse tree composition and shrub composition of planting. We would increase the abundance of climate resilient species. We would design a model for an adopt a tree program. Maintaining and increasing open field species of interests, I will chat about in the next slide. And maintaining or decreasing the rate of sediment deposition is met as erosion is negligible. We also aimed to create a cost-effective management plan. Overall, our restoration plan would meet 10 out of 11 objectives. On to the trade-offs. So The only big issue is field species versus our plan of encouraging natural succession. The first point is that forest encroachment will rapidly remove viable nesting habitat for bobolink. Whether management action is taken or not, it will not be viable habitat. So the second is managing for bobolink will only meet 5 out of 11 objectives, whereas our plan of reforesting the perimeter and allowing natural succession would meet 10 out of 11. We are choosing to prioritize restoration and climate resilience. To summarize, we recommend scenario 3 due to its balance of forest health, climate resilience, and habitat protection. The threats are outlined as low tree regeneration, glossy buckthorn, and pest wildlife. Our plan prioritizes broad ecosystem restoration while recognizing trade-offs, especially for bobolink and monarch. Next, we recommend to implement, monitor annually, and adapt management based on results. Finally, we aim to, or community collaboration remains key. That's what I'm gonna say.
All right. I'd like to take a minute to acknowledge some of the people who made this project possible. First of all, where are you guys?
There's just this guy.
Oh. Jason Golding and Dr. Rafaela Mayrink, who is in a meeting right now. Thank you so much for guiding us in the development of this restoration plan and providing such valuable feedback.
Jay, thank you so much for helping us with modeling, analysis of erosion, data, GIS work, overall troubleshooting, and always responding when I send you a message at 2 a.m.
I want to thank Dr. Graham Forbes for providing knowledge on pest concerns, habitat thresholds, and wildlife habitat. He has been invaluable.
Anthony Taylor, thank you so much for contributing to the development, especially of our initial inventory, our design, our scenarios, modeling, general Silvics, and just keeping us on track.
I don't think he's here, but Dr. Joe Nacera for contributing necessary information on bobolink and wood turtle.
And Janet, she's also gone. Janet Blackadar for assisting with trade-offs and objectives, and generally just being awesome. So,
big round of applause for them.
Big round of applause for them.
But hold your applause, because I would like to invite the rest of our team down to answer questions. We're going to open the floor first to our client.
For questions.
And then anyone else. Thank you.
Okay.
Thank you very much for the presentation. That was excellent. You might have very helpful information in there. I do have a couple questions for you. You had listed out at the start that there were 150 or so stems per hectare of natural regeneration sustained, and that was significantly lower than what should be there. Did you do any assessment on why the natural regeneration there is so low, or what the kind of risks are there?
Yeah, I think Tim can speak to that best.
Yeah, so silver maple is obviously a floodplain species. It falls and germinates immediately, so if there's issues with, they need a certain threshold of light penetration into the ground. Overall, from our visual assessments of crown closure, they're very high. That fern presence on the property, and then buckthorn, because it tends to germinate under much denser crown conditions, and it leafs out faster and grows faster, it's displacing. Another issue is just because it's a floodplain, there's a potential that any seedlings that don't germinate right away are just swept off into the river, but I ran sensitivity analyses and just general modeling over a 25-year period in an open stand model, and based on the control that we're recommending, it is suggesting that regeneration should improve, especially as you have some trees in there that are exceeding 100 plus centimeter DBH. Some of them have been on the property since 1950, and as they succumb to natural mortality, that's going to open up the crown or the canopy and allow more regeneration from silver maple to come up.
Your status quo scenario said that not doing anything in the field might lead to succession. What gave you the impression that that field would succeed? I don't know if that's the right word to use there. To anything other than field if no management is done?
There already are shrubs present in the field, and we predict that these shrubs would become more dominant within the field as natural succession progresses. Once the shrubs take root, more trees will be able to establish as there is lower light infiltration and the grasses become displaced. And based on that, and also a million research papers that say that old field will generally succeed into a forested habitat over time. Over time, yes.
Yeah, probably longer than 25 years.
Long time.
One more question for you. You saved yourselves the part of the question I was going to have about the trade-off between the bobolinks, because you were habitat of the trees and stuff. But at the end, you did end up recommending the restoration approach. I'm curious if you could elaborate on why you would recommend that approach over the species at risk centric approach. Was that just because the restoration approach met more of our objectives, or was there other reasons?
I think that, yes, it is true that they do meet more objectives, but the main thing was focusing on climate resilience, just given what is projected to be higher flooding in that area, especially on that greenway. I know that a big objective of that, it's also social, it's really close to houses. I think that generally, and I think people know that fields grasses don't have the same rooting systems that trees do, and it won't be as good or as effective in mitigating flood. It also it's kind of a debate, but it was converted to that land, so kind of reforesting it back to what it originally was is a effort we think is worthwhile, and an effort that would improve biodiversity and just flood control, climate resilience, all the buzzwords. Also the hard edge with bobolink. That bobolink habitat is only 0.2 hectares. We also considered the fact that it is adjacent to the west. Sorry. Neill's Flats is to the west, and there are properties in that direction that still continue to be field. Additionally, Burpee's Flats, for example, there are other properties that just have more viable bobolink habitat. That would make a lot more sense to manage for bobolink if that made sense. It's more the size of the property. It makes more sense to kind of reforest it rather than manage for bobolink when that's only one species at risk out of 3 others that we would be maintaining. A little choppy.
I think you addressed all of my questions that I asked last month, so great job, guys. We do have another member of the team here, which is Rich, so this will be the secretary. I don't know.
Oh, Rich.
But anyway, I'll see if I can help with another question.
All right.
I didn't really have any questions, but that's great. I was just curious how you landed on, I'm not sure the exact number, a little over 4,000 hectare in your restoration strip.
Sorry, can you say that one more time?
The 4,000
density.
Yeah, go for it.
So pulling from the Ashton and Kelty practice of silvicultural text, they recommend at 1.5 meter spacing, 4,444 stems per hectare planting density. That strip is about 1.26 hectares, so that's just how the math came out to ensure that optimal spacing.
Well, kind of related to that question. Well, you recall in Forestry 3006, Condition 3006, students in here now, we're just going through this. Remember there was a stand development model?
Yep.
General stand development model. So after a stand replacement disturbance, the stand develops, and there are different points in time where you have more regeneration than at other points in time. You know, in that model there, where would you put that silver maple stand that you're going to bring out? Where would it sit between that?
So just based on the limited regen and those like larger, older trees that, if you look at the historical data, a lot of those were present in the property since 1950. I wouldn't necessarily say it's an old growth because of obviously all the human intervention, but if I were just a hazard from a structural perspective, that's where I would put it. And obviously, your own paper on forest succession, the forest succession triangle, it's based on your environment, your species, and their capabilities. It's not necessarily that it's going to return to those initiation phases, but it's more likely that as those mature species die out, it's going to go back into our understory reinitiation phase.
Okay. Well, one of the reasons I bring it up is Helen made one point when she was presenting about currently the regeneration is understocked in the Auditorium. And so, of course, the regeneration changes naturally over time. What would make you say that it's understocked? Like what data source do you have that substantiate that, back that up? There's currently not enough understood.
Yeah, so Vermont and Wisconsin have done significant research on floodplain silver maple ecosystems, and so I sourced information from them which said that under healthy, mature silver maple floodplains, which we believe that Upper Neill's Flats has, there is anticipated to be 500 to 1,000 seedlings regenerating. We were also very surprised because we did 5-meter radius plots, and in very few of them we found any seedlings of silver maple or any tree species at all, which is surprising in a forest environment because you want those seedlings to be able to grow and replace the mature trees as the mature trees die.
What do you think the biggest driver of that was? And so if you're seeing less regeneration of silver than you would expect in the literature, what's the biggest driver of that? What is causing that reduction or suppression?
Honestly, I think that also kind of leads into what Tim was just saying before. Them not germinating quick enough and getting flooded away is probably considerable. The other thing to consider is just that this was like it's important to consider this was a snapshot in time, and that snapshot in time is very dense canopy and very low regen, but it's one of those things that is kind of expected, like maybe in that snapshot in time, that's a normal amount of seedlings to have in the understory, and within a couple of years, it'll just sprout right up as soon as canopy's open. So maybe right now it looks like it's like alarm bells, but I think Tim said it best. He was like, if regen's going to happen, it's going to happen. They're going to be fine. But
just also the recruitment modeling that was done in open stand model, it does show that as that mature, that older mature canopy, some of the larger trees that are overrepresented in their basal area and their contribution to the crown closure, as they start succumbing to mortality, OSM is just saying based on the sylvics and the site characteristics that regen shouldn't be a problem within 5-10 years.
But it doesn't consider glossy buckthorn.
Yeah.
Yeah,
that's the research.
I would like to bring it back to glossy buckthorn because in each of these plots where we saw low regen, there was significant glossy buckthorn presence, and we know that they have dense root systems. And we know that they outcompete and shade out seedlings when they're trying to regenerate. And so I would attribute that as one of the main reasons why we saw low regeneration.
And that's why it's our main target.
And I think that's right, because the one thing to recognize is standards are dynamic, they change, and we have one snapshot at a time. But in terms of drivers, I would say, well, it sounds like, yeah, would be
Olivia?
Again, with this, when you guys were talking about the management strategies for like pests like deer and porcupine, you guys mentioned something about that dry blood stuff. Is that something you're recommending, and how efficient is that?
Yeah, here, I'll just go back to the slide so you can look at it.
Yeah, it's porcupine or bovine blood mixed with vegetable oil applied directly to the saplings.
All right, yeah. Yeah, it's called Plant Skid. It's a company in the U.S. That acts as a repellent against, or the product acts as a repellent against rabbits, deers, bulls, porcupine, beaver, and you spray it on the boles of the trees as well as the foliage, any part of the tree that the herbivores might want to consume. And When they smell it, it elicits a fear-based response because they smell blood, and that's not something that they're inclined to eat. And they believe that there's predators in the area, which makes them not want to eat it.
Yeah.
Does that answer your question?
Yeah, I was just wondering like how fishing was like.
Yeah, it's also definitely important to note that, and it's something we've considered heavily, because it's in a floodplain, and there's lots of water, and also we're in New Brunswick and it rains all the time. It can sometimes be, we think it's more efficient than not efficient, but application would be, pretty sure, correct me if I'm wrong, every
6 to 8 weeks.
Twice, every 2 months, is what I'm trying to say. Every 2 months-ish. So it would require a little bit more of an intensive, like, go into the property, but we think it'll work.
It would be mixed with vegetable oil, which would increase its longevity within the ecosystem.
Fair.
Because it's, yeah. Trevor?
I had a question about trichopher, the pesticide. Were you guys recommending trichopher?
We had it as like an option. It's not on the market yet, and it's still being researched. I've read a lot that it's being used a lot in the States right now, but it's more like it's more like glyphosate, but more selective, and that's the big pull. You can inject it into the bark, and you can also paint it on, and I think it was just assessed by the few places they've tried it out that foliar application is the most environmentally friendly / human friendly. It's herbicide, but but foliar application is meant to be selective and very effective.
We're not actively recommending it.
It's an option.
We're presenting it as an option to the client for further research.
Do you know if it's has any residual effects, or if it would be permissible for aquatic applications and stuff like that?
Yeah, it's.
It doesn't have any bioaccumulation, and especially in water with a lot of light, its half-life is very short, so it wouldn't stay in the water for a long time.
In theory.
Beckley?
I'd like to talk about bank swallows. You said that they prefer erodible banks for their nesting sites, right?
They only nest in,
But that's always been true, right? So you're in a conundrum, do you try to stabilize the bank with willow, or do you not? But for all times, as long as there have been bank swallows where they let nest, it slumps down, and then they create a new nest. So that's the problem.
No, we think that's probably one of the most interesting things and what we've done a lot of time on focusing on, because erosion was obviously a large concern of the clients, and we wanted to make sure that we had a decent understanding of what just natural erosion was in the first place to see if we even needed to go there. And for the most part, with the Russell equation and with 25 years past, I think in the last 25 years, we got historical imaging to give us 11 centimeters-ish in the last 25 years, or 11 centimeters in that entire time, right?
Per year.
Per year, 11 centimeters per year, which is under a meter over 25 years. But yeah, so we found it to be quite negligible that 6 tons per hectare per year is supposed to be considered natural, and we found it to be 0.0427 for the entire property. It's also not 100% sure that we even have bank swallow on exactly our 240 meter strip, because there are mature silver maple growing in the bank. We didn't assess for that. In hindsight, should have, of course, but it's not 100% even guaranteed that they're in there. Definitely they're foraging there, but they might not even be living in that bank. So we just didn't want to go there, and staking is more of a biodiversity, not so much bank stabilization. But
I think it's also important to note that 10 centimeter per year erosion rate was assessed on the neighboring property, which is not treed. So the treed property extrapolation that tree roots stabilize banks would be lower.
But to go back to your question, which was, what's the problem? Why should we protect these species? There are species at risk. So it's something that, under the Species of Risk Act in New Brunswick, we need to be conscious of.
Do you know why they're at risk though? Are they at risk because they lose their nesting habitat, or are they at risk?
Might be
for
because
something
people are
else?
obsessed with controlling erosion.
So the risk then is partially nesting habitat loss with erosion control. And the kind of the consideration with this project was managing that interest in erosion control on the river with preserving that habitat. The biggest risk to their nesting habitat is through like hard erosion control with like stone and those types of materials, which we wouldn't implement for multiple reasons, but especially with that consideration. We're not proposing direct erosion control right on the bank, which would impact it wouldn't impact the existing bank swallow, because that, I don't know how far back that patch that we're proposing, the willow.
Oh, it's like
is,
15,
but it's not
25
right on the
meters
bank.
back or something?
Average.
Yeah, it's about 25 meters from the bank.
Yeah, but
Give or take.
that is kind of the thing to consider here is erosion versus keeping the bank swallow. But I didn't think, and we didn't determine it to be a risk for the measures that we're proposing. But yeah.
Yeah, I'm just spitballing here, but, because, you know, for some species, like we make Nashwaaksis, right, for the ducks and so forth, like, did you consider the possibility of like poking holes in banks to kind of like be a
I've never
home
considered
for a
that.
bank swallow? All along the river, so that there's.
I certainly haven't seen that as a management technique for bank swallow. But I don't know if that, I mean, they do have the behavior of excavating, so that might be necessary.
Are we done? We're done.
Yes.
I don't know, ask Gavin.
I'm curious about your plant a tree program, like to engage the public and get them excited about co-stewarding stuff here. You said that you'd be very happy with the 30% survival of your hardwood trees?
In the first year.
In the first year. But yes.
So in the first year, 70% of your trees die. What are you going to do to deal with the trauma of the
Right.
people you've recruited to love these trees? And then
Definitely.
Yeah, no, we've considered that.
So that's why we would be implementing the Adopt a Tree 5 years into the program. Not in the first
immediately.
year. We've thought about
We
this.
did think about that. We're thinking about people's feelings all the time.
So we would be adopting out the trees that are already doing well, based on like survivorship.
So that we don't pull anybody along.
Yeah,
Just be
yeah.
mean.
Could be very devastating.
Yeah.
I'm impressed that you thought that through. One last thing, and this is like, many of you know, I have trouble with my hardwoods and trying to protect my hardwoods. And your tree tubes, how tall are they?
You can get them in a range of sizes. So we're recommending like around 30 centimeters to, what?
No, I'm sorry, they just want us to stop so bad.
Oh.
Go.
30 centimeters to 50 centimeters in height. So we're already recommending trees that are between a meter, wait, no, not 30 centimeters. That's too short, my bad.
Back it up.
Back it up. So between a meter and a half in height are the tree tubes that we're recommending for this property.
And the trees we're recommending 1 to 2 meters.
Yes.
Is that, I mean, if you have a meter and a half,
Yeah.
it just seems like you raise them up to the size that the deer don't even have to bend over to eat.
Yeah.
Yep.
Above the deer's browse line.
That's 2 meters.
That's 2 meters.
2
It's
meters.
considered to be 2 meters. I briefly mentioned it, but let's.
Read it in our report.
I just put fences on all of my oak fences, because the first ones weren't tall enough, so.
We can chat about it after.
Thanks.
Thank you, everyone. That concludes the 2025 4020 presentations. I hope you guys all feel super proud of everything you've accomplished these past 2 semesters. Your hard work does not go unnoticed. Thank you to the faculty members and the clients who helped us along the way, and big thanks to Jason and Rafaela. Congrats, everyone.
Silver Ring social hours at 5.